All right. Hi, everyone. Hopefully, y'all are all still fairly awake after eating lunch. I'm not that much because I'm having some pretty bad jet lag today. Originally from Texas, but I live in Ireland, so I'm adjusting to my flight yesterday, apparently. So this topic is kind of a more advanced track than this morning's track was. I wasn't there for this morning's track. I wasn't fed what the slides were, so if there's duplication, I apologize. But better to go over something twice than never. But anyway, so the topic is digging into Mongo advanced session. Who am I? Why am I even here talking to you? So I'm the principal DBRE at Udemy. If you don't know it, it's a learning platform, but I'm over all of the database technologies we do. And the reason I'm over those is I used to work for Electronic Arts as the global MySQL and NoSQL architect. So Cassandra, NewSQLs, RIAC, Mongo, MySQL, the whole gambit. But also I did stuff with Mongo specifically. I was the lead DBA at Object Rocket, which is still a thing today. But even before that, it was kind of the first one that was really a Mongo as a service and did high performance Mongo, especially sharded Mongo, and dealt with a lot of the hard problems. And they had really large customers that did very strange things with early Mongo. I'll say it that way, especially before WiredTiger existed. But we'll get into why WiredTiger helped with that stuff. But also, I'm a Mongo Master alumni. What that means is when Mongo first started kicking off, there was a group of us that were community experts that went to sessions with them and communicated with them and helped drive where Mongo has gone today. I was one of those people. And then also, I put source code into Oracle, MySQL, Postgres, Mongo. If I touch it, I'll probably find a bug or an annoyance somewhere or a feature I need and do it. So that's why I'm talking to y'all about this stuff. And a lot of what I'll say here might apply to your use cases. It might not. But I think it's good for everybody to understand the topics. And so this is kind of how I broke it down for us to go through it today, is just a quick overview of system and architecture kind of stuff, file systems, types of storage to use, that kind of stuff. And then replication and sharding patterns that I find useful that people should think about that Mongo doesn't talk enough about. Same thing is true about memory and advanced WiredTiger settings. I want to kind of go through a few of those things so that people understand what they're setting, because according to Mongo Inc., that is, you just turn it on and it works and it's always going to scale forever. It's totally not true. I've done terrible, terrible things with Mongo, but also cursors and driver semantics we'll get into. Obviously, security roles and features we'll talk about a little bit too, and aggregation pipelines. A big thing that to pay really close attention to in this talk would be especially around the shard management stuff. Because when you get Mongo at scale, this is what's going to burn you. The patterns that I'm going to talk about, those will burn you if you don't do them right. And sharding, specifically chunks and jumbos and stuff, will hurt you. And there are, as much as Mongo has improved the sharding ecosystem and how it does splits and all that stuff that I'll talk about with y'all later, there are still some very big deficiencies. And I think there's even still a ticket that I opened up in Mongo 1.8 that was about creating hotness-based shard balancing as opposed to storage or document-based balancing, because multi-tenant is a thing. And I do have a pattern I talk about on how to try to help deal with that. But then we'll talk about some disaster and some BCP type stuff and some basic monitoring stuff. And then I hopefully will have some time left, because originally I had thought this was going to be a 4-hour session. And then as we started planning the conference more, we realized it was going to be 3 hours. Also, I'm one of the 2 Mongo committee members for the conference. So if y'all feel things were missing from the sessions this week, talk to me, let me know, because I think that's really good feedback for us to know, did I not get submissions on those things and I need to ask for those more next time? Or did I rate those lower than I should have? Because I am a human. But anyway, so that's our agenda. So getting into it, don't want to spend a lot of time on this. I assume everybody here is pretty familiar with Mongo, right? Cool. So basic design. The only thing that I didn't put in this that I really wanted to talk about that not enough people talk about is do not, for any reason, put a load balancer in front of your Mongo S's. There's two reasons for this. One, Mongo's command protocol semantics attempted to be stateless but are not stateless. And the second one is when you connect to a Mongo S and you get a session for the Mongo S, it's going to get an ID for that cursor. And so when you make a new connection through a load balancer, it's going to present that ID. The problem is those Mongo S's don't talk to each other. And the same session ID could exist, and you could consume another user's data or another query's data if it was a long-running cursor. When they changed the driver to do this, I had about no less than 80 hours of screaming at the CTO and CEO of Mongo about it when I was at ObjectRocket, because it was the single most boneheaded move from a Mongo command protocol perspective they could have ever done as far as what people are going to get hung up and confused on. And so you'll be really tempted to put Mongo S's behind, say, an auto-scaling group in AWS. Sounds like it would be a great thing. But if you put it behind an auto-scaling group that's also using an NLB, you're going to hate your life. If you put it behind like a round-robining DNS, not as bad, but you still run into certain limitations. I'm more of a fan now than in previous versions of Mongo to run Mongo S's locally. Before, I was very, very against that. And later on, when we get into some of this sharding stuff, I'll talk about why. So the system architecture kind of stuff that I wanted to go through is kind of this type of stuff, which is memory usage, engines, how to heat it up, storage concerns, EFS and NFS also concerns that I wanted to talk about separate from, say, normal block storage, iSCSI type considerations, virtual memory, and file system stuff. So the first and most important thing is most people don't know this, but Mongo allocates about a megabyte of memory per connection. This is really important for you to understand because that memory isn't necessarily marked as cacheable. And so the kernel doesn't allow you to reuse it a lot of times. And so you could starve your system if you have your WiredTiger cache set too high and you have a thundering herd type problem with your connections. Like the whole thing could just become a complete, terrible, nasty mess. The other thing is there is no query cache in Mongo. This is by design, this is intentional, because the intention of a document database is these things are changing and evolving rapidly. You don't want that type of cache. You're not going to get the value out of that type of cache. You can have different, that'll make it a cache-like design, or a write-through cache-like design, I should say. The other thing is we'll talk more about deduplication compression on disk and versus in memory. But the important thing to consider is compression is only a storage thing. It is not a memory thing. It is not a compute thing. It is not a transferring to the client thing or a client consumption thing. Any long field names you have, any repetitive strings that you have, those are just going to take up extra bandwidth and compute cycles. And that's just a fact of the life. Mongo doesn't talk enough about this, in my opinion, because I would love to see better on the wire compression options and deduplication options, but they don't exist. The other thing is with the memory breakdown, I try to keep this kind of 50 to 60% split most of the time, but when I say in heap memory, I'm not talking about the WiredTiger cache. I'm talking about the WiredTiger cache plus any ongoing operations such as chunk splits or balance actions, things like that that could be occurring, indexing that could be occurring, file sorting that could be occurring, or in fact, connections. All of these things add up into that 50%. But it's very, very hard to model the beauty of Mongo is it's very abstract and able to fit to your use case that your developer has today versus tomorrow. The danger of it is, how do I predict what my memory footprint, what my hotness is going to need to be? How do I make sure I don't let them OOM the system? And it's not a great option other than good monitoring. I wish I could give you a better answer there, but unfortunately, we've given so much control away that we don't have a lot of those mechanisms in the Mongo system. So I wanted to talk about a bit about the engine. So in the past, we had, let's go through this. We had memory map, we had WiredTiger, we had Percona FT, and we had RocksDB. Obviously, Percona FT and RocksDB are no longer in modern releases. If you want, I can talk about later on in this session why those things existed, why those technologies are interesting, but why their upkeep is too much to maintain keeping them in the stack. Specifically, Percona FT is what I have a lot of knowledge about, because when Percona FT was a thing and when we were retiring Percona FT, those were decisions I made as the practice manager for Percona. So I have a lot of relevant reasons why I made those choices. But the biggest thing I want to talk about is, so Percona has an in-memory engine option for Percona server for MongoDB. MongoDB also has an in-memory option in their enterprise flavor. You might be, if you actually looked into some of the WiredTiger options, there is this write in-memory option. And you would be correct in looking at it and going, well, why do we need a separate engine if I have this flag I could set on a collection or on the whole system? And the answer is, it comes down to checkpoints, syncs, durability, all of these things that even if it's in memory, it will still try to do all those durability actions, even though it doesn't need to, if you just set this one setting. And the other engines attempt to simplify this process by just saying, switch to this engine, and you don't have to worry about this. We'll make sure that all of that stuff is turned off. One of the differentiating factors, as you see here on the slide, and I made these slides, I'm sorry they're wordy, but I made them so you could go back to them later, you could look at them later. But one of the big things is, in memory supports some on disk features and some not, but the collection level versus document level locking is probably what's gonna burn you if you're not paying attention, because that is a very real limitation of the Percona memory engine versus just setting this right in memory setting. If I was running something, say I had and I'll talk about this pattern here in a minute, but say I had a shard that was running in memory, and I had a hidden node that had persistence turned on so that it best effort to do persistence, but if I lost it, it's session data, users could log back in. Not the end of the world, it's not my orders, it's not some other critical data that I don't want to ever have a chance of losing. Then WiredTiger in memory is probably what you want, because session stuff changes real rapidly. I don't want collection locks on that type of setup. However, the challenge therein is I'm still taking the hit for those checkpoints and other things. So I might need to tune down my checkpoints, and we'll talk about some of those settings here later, but I might need to tune down those checkpoints if I'm using WiredTiger in memory, because I want that document level locking. And so of the storage engines, that's probably the biggest differentiator today, is does it do the metadata stuff that normally would come with persistence still, or does it just do no persistence? WiredTiger does no persistence, not WiredTiger, Percona memory engine does no persistence, but it sacrifices the ability to do document level locking. So if you shard out with lots of small shards, that's fine. If you only have a few big shards, that's probably going to burn you and you're probably going to have an incident. It's just a fact of the life. The other thing is like, when we talk about that, I was talking about the persistent store, and just overall, what does WiredTiger give us? It gives us that persistence, the larger data sets, the not having everything in memory. It has some compression stuff, but again, it's only for storage size. We'll get into the settings around that. And also an interesting fact that I didn't know until I started looking at this, because I'd never tried to do it, is in memory, you can't use secondary indexes apparently. I didn't know that, but that's in the Percona documentation. I've always used in memory as if I was trying to have a Redis or a Memcache type system, but I didn't want to have another set of drivers, another set of database connections. I wanted it to be in the same ecosystem. And so I never thought to index with a secondary index. So I learned that myself. I had never looked at that. So as far as like heating up caches and stuff like that, you can do it. You can do stuff like what I'm doing here. Honestly, while I can do this, I can heat it up, I can do certain stuff. Indexes I might do this on, but I have a hard time myself justifying in case, except for very unique use cases, why you would ever do this in WiredTiger in general, because everything is completely random. There is no guarantee of ordering on disk with WiredTiger. And so it usually is roughly on insertion order, but if I've inserted a lot of data and then I deleted 25% of that data and then I've inserted more data and then I do that 30 cycles of that, I'll end up in a place that everything is completely random. Nothing is sequential really, until I do a replica set rebuild. And then at that point, it would sequential in because it's read in and inserted in that order again. And so there's things you can do to get rid of that randomization, but in general, this type of heating up the cache, it doesn't make a lot of sense to me. I would probably try to figure out something else, like what were my last 10,000 objects in my application store that I got on startup. Let me go pull that from a Kafka topic or something like that to rapidly heat up my Mongo. I would probably be doing something like that because that would be more reliable and consistent for warming things up than trying to just, blindly read a file to warm it up. Because of this collection 0, blah, 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 how many of the records in that file are actually going to get read before they get evicted back out again? I don't know. But it's important to know that you can do this, and the command for that is touch, and you give it a collection, you tell it data, you tell it index, and it can load that rapidly for you. This is a much better approach than this older way. But even this has those same limitations and problems. You can, in fact, iterate over the WiredTiger file and get the records out of it and then do selects on that as well. I've done stuff like that as well. There's a whole bunch of options there. So that's kind of the engines in a nutshell. Does anybody have any experiences you've had or questions that I can kind of cover on the engine section before I move on to actual storage device type topics? Okay, all right, so when it comes to these slides, I built it mostly around AWS. It's what I use the most lately. And so I think it's what a lot of people that use Mongo are on in general. I don't hear a lot of people using Mongo on Azure. I see them using Cosmo a lot more personally. Your company might be different, but I'm setting up some basic rules here that I will break later in this topic. I will talk about why I'm breaking them, and I will talk about why it makes sense when we get to the tiered sharding pattern, which is a specific pattern on, well, what do I do if, as my data ages, it's less valuable to me, I don't care about my responsiveness of that older data as much, blah, 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 blah. we'll break some of these rules. But in a general thing, magnetic storage is terrible for Mongo. Like from an EBS perspective, you're just going to be wasting your IOPS. You're not going to get the performance you're looking for. It can be used. There are some viable workloads that it could be useful for, but generally speaking, I stick in the GP2, GP3 realm for 80 to 90% of my use cases. That's the point of Mongo. The point of Mongo is I don't need to jump into the IO2 systems. I don't need provisioned IOPS. I can just have more instances spread out with more EBS devices as opposed to fewer, bigger types of things. And this is important because IO2 is significantly more expensive than GP3, even with GP3 provisioned IOPS. However, this gets into an important thing. How many disks do you attach to your Mongo instances today? How much of your possible EBS bandwidth are you able to consume with that? So you're using 2. If you are using less than an 8x size instance, say you're using a 4x type instance, you're only at maximum able to use 50% of the networking speed available to that instance because your number of disks is limiting you. And so keep that in mind. Each GP3 volume has a 1 gigabit throughput limit. So your instances, depending on the instance size, it's all very variable, are usually somewhere between 1.5 and 4 for the smaller type instances. And then it goes up to 10 and 15 and whatnot on those larger instances that guarantee speeds. Speaking of that, if you are using smaller instance sizes with EBS, the other thing I like to tell a lot of my teams and people that I work with. Okay, I was about to get to that. That's exactly what I was talking about. So there is a magic number in AWS, and that is 8x. At the point that an instance is an 8XL, you are guaranteed resources on that machine. You are big enough that you take priority on that hypervisor. And at that point, instead of saying you have up to 10 gigabits of EBS networking, it says you have 10 gigabits of networking. And where this matters a lot is, what does up to mean in AWS terms? Does anybody know that definition? No. It's actually a very specific thing. What up to means is that twice a day for 30 minutes, you can hit that maximum number they just told you. That is your burst balance. If you have consumed your burst balance, it is, depending on a whole bunch of factors, somewhere in the neighborhood of about 20% of the max that you can consistently hit. But when you magically move to that 8x node, you're now always hitting that. You're no longer doing the bursting. And so that's just some interesting AWS knowledge for instance sizes and planning, to where you might benefit more for upgrading a node from a 4x to an 8x than to go to an N-type class for the same thing or moving into another instance type family. And so if you're close to that 8x, pay a lot of attention there. Look at what your EBS burst balances are and your network bursts and stuff like that on your instances, and see if your problem is fundamentally that. The other thing I would say about a lot of this stuff is, if you are not on a Gen 6 AWS instance, ask yourself why you're paying to be on, it's paying the same money to be on slower hardware. This is especially true when it comes to your network devices. The difference between a 5 and a 6 from a network signaling speed is not unsubstantial. It has been measured. There's lots of documents out there on it. But just kind of calling that. But if you do find yourself in very large unsharded setups for whatever reason, IO2 is a great storage medium for you to use. It can get you on a per disk basis and on a per instance basis much more performance, especially if you're choosing an instance type that can avail itself of IO2 Express. It's fairly new in AWS terms, but it is astounding the amount of bandwidth and throughput those things can push just by being on the right kit. And then finally, there's the ST1. Again, I was just talking about sequential a minute ago. I'll talk about it again when we talk about read ahead, but sequential for Mongo doesn't make a lot of sense in most cases. It just doesn't. But if you were using Mongo as an IoT stream of data, if you were using it as an event log store, things like that, ST1 might make a lot of sense. It's a lot cheaper than GP3. I might not care about the speed of ingesting from whatever my message bus is. And so I might actually save a lot of money there that I can reappropriate into having a bigger Kafka cluster, Rabbit cluster, whatever you're doing for that message bus for those event streams. NFS. It is fairly crap for Mongo, even with WiredTiger. It was way worse with memory map files. But the problem still is it's very inconsistent with what its performance profile is going to look like. And so you can end up with a lot of microstalls and weird behaviors that happen. And in Mongo, what can happen here, because unlike MySQL, where MySQL, if I start a transaction and I change something and then I commit it, those things happen in that line. In Mongo, if I have 4 writes, they come in at the same time. And I should say this, 4 writes, they come in at the same time. If this write here goes in, these other 3 will all get an error when they try to write to the storage engine that retries automatically. It's hidden from the user land perspective, but they try again. And the reason for this is my queries might be using an increment value. They might be using a whole bunch of stuff. And so it's basically resetting its state to get the latest value of it. And it's pessimistic versus optimistic locking. There's talks that and documents that you could read on that. But because of that logic of being that optimistic lock, NFS doesn't play well with Mongo in general. Because those pauses can create a whole stacking effect of retries that could occur there. You can measure this in the engine statuses. There is a metric that lets you see how many times these write conflict exceptions are occurring and how to deal with them. The other thing I wanted to kind of say here is AWS EFS is still that. You could be tempted, and I have seen people tempted to use EFS. It has provisioned IOPS on it. It has throughput mechanisms on it. But it also lets me say, okay, well, node 1's in this folder, node 2's in this folder, node 3's in this folder. If I need to start up a node, that I can just literally point it at this other folder, and it'll be like it was that node already. Very little effort to repurpose shard A to shard C, for example. But it has the same performance problems as any other NFS system. And so you can be aware of it. There's things you can do to work around it. I don't find it's worth the effort. VMware is a whole different beast. In multiple clients that I had when I was with Percona, and since then, I've measured this. And the whole VMware uses an iSCSI mount to get VMS on a system. It uses VMS to start up instances and for the VMX file and all of that kind of stuff, and the VMDKs, which are the virtual disk files. Then if your Mongo is then stored into that virtual disk file, now you have an abstraction layer, which is the file system. You have an abstraction layer, which is the file in VMFS, and then you have a block storage. And that going through those layers amounts to about a 30% overhead. Compared to like literally just iSCSI targeting that LUN from within the Linux inside of the VM in VMware. Crazy how much more performance you get out of that. So if you're using VMware, I don't know that many people that still use it for a database related thing versus like VDI type stuff. But if you are using it, be aware of that type of setup. So read ahead, I kind of already talked about some of this a bit. It can waste a lot of IOPS. It can waste a lot of just RAM and compute cycles and a whole bunch of stuff. So the randomness we've already talked about, so I don't want to harp on that. But also the aligning the read ahead to the number of KB that your block size is going to be is very important. So that if I'm getting block 1, I don't also ask for block 2 or 3 or 2, 3, 4, 5 or whatever it is based on my read ahead, if I know I'm probably not doing sequential stuff. Because what you need to ask yourself in this type of scenario is, what is the ratio of read aheads that have helped me versus read aheads that have wasted IOPS that could have been better served for faster writes or other reads I needed for my cache? I can't give you a good measure on that. It's very hard to do it. You need to understand your workloads a bit. But the thing that helps do this the most is by setting the set RA to either the document size or 2 document sizes or whatever the right ratio seems to be in your use case. And again, if you are regularly rebuilding your replica members, maybe you could leverage this because of the way you're accessing stuff. It would be clustered together in a good way in that design. All depends on the underscore ID of your collection and all of that fun stuff. But this is how you would do that. I generally kind of ignore read ahead if I'm in AWS. And I just don't do much other than tune down the block size, if anything. So this is how you can kind of set rules for if you are doing read ahead rules so that they will always apply in a consistent manner. This is really quite useful for things like EBS that might decide that XVDC is now XVDD. That can happen. And so depending on how you do these changes, you could benefit from it. I use these rules in CentOS-based stuff. I know you can do similar rules in Debian-based stuff, but I think the structure and the way you go about doing it is slightly different. Okay, so file systems. So with file systems, I don't think I have run a non-XFS database in about 3 years. That's a bold statement because XFS has some challenges when it comes to FSIC and recovery and stuff like that if it goes south. But the performance benefits pay off, especially in Mongo, where how do we rebuild a Mongo node if it went bad? Just flatten the disk and start up the Mongo process and let it heal itself 90% of the time. So in that kind of case, I would rather get the throughput from my system than the guaranteed journaling consistency that EXT would give me. That's a choice that I've made in a lot of my architecture. It's a higher throughput, and that is because EXT4 has more journaling and inode checking and a whole bunch of other stuff in place. It's the same thing that where we were talking about ZFS or ButterFS or any of these other types of systems out there. There's going to be trade-offs on how much logging they do to make sure they can recover to a specific point in a hardware failure, and how much they accept that a block might be corrupt because I view my data as more transient in nature and I can rebuild it. In a MySQL system, I would not be making the same claim. In a MySQL system, I would want that consistency because it's a lot more effort to rebuild a MySQL node than a Mongo node.
If you have your data and journaling capabilities, the general recommendation is to potentially have the journal in ext4 and I worked somewhere.
Oh, so sorry. So you're mixing file system journals and Mongo journals together. I'm talking about file system journaling right now. And so you are right. There is the sequential nature of a journal file versus the random nature of a data file in Mongo where you might want different devices for that. I don't generally do that, and there's one simple reason for that. Multi-disk snapshotting sucks in AWS. And snapshotting in general sucks in AWS because it's not like I can say snapshot and at that exact second, I know a snapshot has occurred. It might be a minute from then. And so as a result, anything that makes me cross disk barriers that's not just me doing RAID 1.0 striping with like MDM or something like that, I personally avoid because I'm never going to get a consistent snapshot. I do take snapshots of all of my database instances, but I don't rely on those existing. Those are more there in case I find that some huge corruption issue occurred, that I have some other place that I might be able to recover that data from. It's not. You can do that, but how long do you need to freeze that for? You have to keep hitting the AWS API to check until the snapshot has started before you can unfreeze. Because otherwise what you might have is shard A, you froze shard A and shard B, and what you might end up with is shard A snapshot started at T plus 4 seconds, shard B's snapshot started at T plus 18 seconds. And I'm not in a consistent state unless I left them both frozen until T18.
So, forgive the question and the analogy. Coming from the MySQL world, like when I'm doing snaps, I tend to shut down the database, freeze the disk, unmount the disk. Granted, it's a little bit of extra. But even for a multi-terabyte snap, at least in GCP, it's only like, I don't know, a minute or so.
It's not the time to take the snap. It's the time for the snap to get scheduled by a worker in AWS.
So AWS, I guess, doesn't necessarily start.
Yeah, so basically what happens if you want to get into the nuts and the bolts of this, is you send an API request to AWS to say snapshot EBS volume 1234. That goes into an SQS queue that then their workers work through. And so depending on how big that queue was at that moment for that specific set of underlying storage that your EBS happens to be on at that moment, you might get an instantaneous response. I'm starting it, that snapshot. And the second the snapshot is started, you could unfreeze things. You could remount things. But until it has started, you run the risk of, again, like these two shards being at slightly different temporal states. Right, but if you're freezing and unmounting based on when it says that it started that snapshot on an individual node, then you run into that temporal problem. What I'm saying is, if you are going to do snapshots, you have to make sure you look for the longest pole, and that's what your unfreeze element is.
So what might be some of the delays? Like what are you going to see? Like we're talking about seconds, minutes, single-digit bits, or multi?
In recent years. In recent years, I've seen it more frequently in seconds and occasionally minutes, but you are absolutely right. I can go back to some of my memories in 2010, and I had at one point, and I think it was a GP2 at that time, I had a system whose snapshot took 6 hours to start. Yeah, it's been a while. Like they've grown their storage fabric quite a bit since then. I haven't seen hour-long ones recently, but it also depends on your storage type. Very heavily depends on your storage type. Like I was talking about those 4 before, and depending on the characteristics of those, there's very different profiles of how snapshots work. In fact, so I think everybody that's used AWS for a while has heard the adage that if I've taken a snapshot and I want to use it on a new machine, I have to warm up all the blocks. Did you know there's a way around that? Well, there's their service to do it, but then there's the other one of start it up on an I/O platform and then immediately downgrade it to GP3 because it will be provisioned instantaneous because it's an I/O. It's a sneaky, sneaky little thing that only costs a few cents, and it's actually cheaper than their, I forget what they call the service, but there's a service they have that you can target a snapshot and say, warm this up automatically so that when I use it within the next few hours, it'll be hot for where I'm going to use it. They have a service they built on it, and it has a limit of how many gigabytes per hour that it can process and stuff. And so it is really good and useful. But if I'm only on that IO2 for 10 minutes, I'm probably saving more money doing that than that constant cost of that using that one service that is always charging me for the number of snapshots that I have warmed. And so this isn't an AWS topic, but these are all the things that we worry about with storage kind of questions when it comes to this. ext3, I don't think anybody's using it anymore, but it did have some allocation speeds when asking for a new file that were significant. And again, ext4 will work. It just, there's some extra overhead. You're not going to get the same level of throughput out of your system. I did want to say some settings that are useful, especially for ext4, the no A time, the no dir A time, no quota, and log buffs are all quite useful depending on your use case. The no quota is an interesting one. Did you know that even if you're not using quotas, your file system is being slowed down by not using no quota? Because there's metadata tracking that's still occurring. A lot of people don't know that about the Linux kernel. In most cases, it's not a huge amount, but it's something. And depending on your systems, it might matter. The ones that I find very, very questionable are the inode setting, the no barrier setting, and the Alex size setting. Depending on your underlying storage, depending on your use case, these things could be useful or not. For example, if I know that I have large collections that are sharded and they almost always have at least 2 gigabytes on disk, there's no reason I wouldn't use an Alex size that would be 500 megs or something like that, so that I'm only doing 4 operations to allocate a 2 gigabyte file, as opposed to lots of small ones. But if I have lots of small collections and my developers just have a free-for-all on what they're storing, and each one of those creates a separate WiredTiger file, that alloc would be allocating that space for every single one of those small things. So I might have a collection that's 500K that's now using 500 megabytes. And this is why I say it's questionable, because it's so based on your use case pattern of your users of your database that I can't give you a recommendation on if you should use it or not. Log buffs is kind of the same. Tweak it only if you know what you're doing, but it's a way to speed up certain metadata operations on the file system, but you need to understand what is my throughput, what is my concurrency, what are my IOPS, there's a whole bunch of things that get baked into that. The other thing I'd say is, regardless of what you're doing, have a separate LUN partition, whatever you want to call it, block device for your database data. As I already said, I don't usually separate out my journal, but again, that's because I can't take that consistent snapshot for certain recovery operations I would like to do. I can try. It might help, it might not, but I take snapshots of every machine, even the one that is currently the primary. Because I'm not freezing them. I am taking those snapshots because they're not my backup record. They are my get out of jail free emergency record. Yeah. It depends on the value. On the value you place on that. Yeah. I'm usually keeping those types of snaps. The top level snap, the happens once an hour type snap, I'm keeping that for a day. And then I'm keeping a weekly, and then I'm keeping a monthly. And and that monthly goes to Glacier, the weekly will vanish on its own. The hourly, that is literally just there in case I hit a Mongo bug, everything got corrupted, and I want to see if I can just restore my state to a certain snapshot rather than restoring a backup. And that's really where a lot of that comes from. But it can be prohibitive. That is why I have very strict life cycles on those types of things. It is also one of those things that it's, am I overly cautious with what I'm doing in the use cases that I have? Yes. Am I overly cautious for certain reasons of really bad design of people putting things in Mongo that shouldn't have ever been in Mongo? Also yes. And so I'm having to do a lot of defensive maneuvers in some of my stack setup to make sure that something that should have stayed in MySQL that might have some financial implications to it, I can always recover from whatever went wrong. And also some of this is experience. I don't know if y'all were using Mongo at the time. There was a point in time that if you ran 2 ensure indexes at the same time, Mongo would delete your database. Just dead. And so I've been through some pretty terrible things with it, so I might have some PTSD on that front as well. But again, I would cut back the number of snapshots if I was asked to save some costs. That's something I could do, and I would talk to people about the balance of that.
To me, that seems like a good, like when you just laid it out for the snaps, seems to me like a good balance. Because I mean, you need to have at least small ones and they're pruning like
Yeah. Yeah, and especially because like right now I don't use Percona's backup tool for anything that I do because everything I have should be encrypted. And Percona's backup tool takes a backup, but it's not encrypted. So not ready for my use, but ready for a lot of people's use. Because there's a lot of companies that as long as it's going onto an encrypted storage backend, that's good enough. In my company, that's not good enough. Like they expect data file level encryption to be occurring. But anyway, so there's that. We kind of already talked about LVM and MD type, striping and stuff like that. The thing I will say, I don't use LVM. The reason I don't use LVM is if I, after the fact, need to add extra disks, I'm looking for more capacity for some reason. LVM will not balance that. It will still have more blocks on the original device and less blocks on the new device unless I was to trigger a rebuild of that replica member. And so what I prefer to do is use MD so I can add a device, add it to the MD thing. It's going to redistribute those blocks evenly. I'm going to get better I/O and throughput.
With MD, which version of RAID do you use?
I use 1.0. I just do normal striping because I don't want the extra overhead of like a 5 type setup. But the striping allows me to make sure I have evenness of blocks across the disks I have. The downside, obviously, you take a performance hit while MD is doing that rebalance. So apples, oranges, take your pick on what the appropriate is, but that's why I don't use LVM and why I trust MD more is because I care about evenness of spread. If you haven't noticed, I'm really big on this 1 gig limit for GP3s because I run into it all of the time. Like 90% of the time, if I realize that a database system has an I/O issue in Amazon, it almost always tracks back to that maximum throughput of a single disk.
Do you run heterogeneous or homogeneous environments for the RAID time? Or using like 2 GB3s or like 4 GB3s modeled together?
It really depends. If I'm looking for more throughput on when we get into the tiered approach, I might be heterogeneous where the shard that is my hot shard gets gets more of those. But generally speaking, my overall rule is everything in your Mongo cluster should be the same. That is my overall thing, because at any point, any member of a replica set should be able to do anything. And I'm going to talk about that here in a minute when we get into some of these patterns right now. Because in that, I am going to talk about that, because that is one of the things I see people try to do, and it's terrible, which is put certain indexes on certain members of a replica set. And I'm just like, no, because then you have to hide it or lock it or do different things to keep the one with the wrong indexes from becoming the primary and making your whole life terrible. And so there's a couple main patterns. So there's the normal kind of using replica member tags and ranges kind of thing. There's the satellite pattern, there's the BI pattern, and there's the memories for write with eventual persistence. And so overall, kind of the main three use cases I normally see for people trying to do are location-based distribution, and I have a diagram. I'll show you all that in a second for each of these three. There's the workload isolation, so BI doesn't get to touch prod. Y'all can hit this node, y'all can do your selects on it, but there's no way you can all of a sudden cause my user throughput to drop by 10% because y'all decided to scan the entire database for whatever reason. Because I don't want to stop the data team from doing their job, but I also don't want them to make a user instant simultaneously. And then there's the indexing localization that I was just talking about. So if you've not used tags with Mongo replica sets, I have some commands here in a second I'll show you, but basically all it is when you're adding a member, you can set some tags to it, and then the read preference can then use that when you're querying. And that's how you can get some pretty good stuff. So like in this kind of case here, you can see I just did a basic setup, but what I have is I have a VPC, I have 3 availability zones, I have 3 Mongo nodes, 1 in each. And when I'm setting up the replica set config, I'm saying zone A, zone B, zone C, basically. So then what happens is apps in availability zone A can just be tagged with a read preference, like is right there, read concern, zone AZA, and they will go to their local zone first. If that node is unavailable, it'll go cross AZ and do cross AZ bandwidth billing and slightly extra latency. The same thing could be done if you're doing multi-regions as opposed to just availability zones in this kind of case. But still the point being, that's how you use tags in a very simple way with replica sets. This is going to be important because later on we'll talk about sharding, which is going to use shard ranges, which is a more advanced form of the same idea. So the workload isolation, same basic principle, except instead of using zone, in this case I used environment, and the first 3 nodes were created with prod. The BI node was created with BI. Couple things here. I made the BI node hidden, and I left its priority as 1. I could have set it to 0, but I made it hidden for a couple reasons. The first reason is I don't want production traffic to grab and see it by default. I want BI nodes to be told they need to use that flag to connect to it, but I don't want normal traffic to accidentally go to that node and create weird behaviors. And then the index localization, talking about this one, it's very much like the workload one, except you might have certain indexes on certain machines and want to do read preferences there, which sounds like it would work, but it doesn't work out the way you would expect, because at some point you're going to have an election, and then do all of those queries now go to the new primary? And the queries that went to the old primary now go to another node once that node recovers? Like, there's a lot of questions on how you would do that. I don't like that pattern. I would much rather use a sharding approach to this problem, which is create a shard that is for a certain application flow or collection or whatnot that has optimized indexes for that. as opposed to replica set members. Because again, replica set members should be identical inside of a single shard. All right, so let's see, where am I at time-wise? Okay, 2:30. Okay, so sharding, I'm gonna do a quick primer on sharding, but before I do that, does anybody want to talk anything more on architecture or storage stuff?
I was just, you said this was about AWS, and I was curious about instance types, because a lot of times for MySQL databases, there's the use of the RX instance types because they're memory occupied.
Yeah.
My understanding is that Mongo might be more CPU intensive than MySQL, and what is better, in your opinion?
So Mongo can more effectively scale the cores used. So I wouldn't say that Mongo is more CPU intensive as much as Mongo can better leverage those extra cores. But in both cases, I typically go with R6Is in most cases. I do this for a couple reasons, but the first reason is the clock speed of the R6I is a nice balance point because it is a faster clock. And so when I go over to the Cs, I might have more cores, but each core is slower. Huh? I haven't, I'd have to go back and look at M's because I haven't used Mongo in a way that needed large memory, the same way my Redis instances would use an M, in a very long time. I sharded my Mongo quite wide as opposed to up. And so with the M's, I'd have to look at the level 2 cache, I'd have to look at the memory frequency and a few other things to make my determination. But if it's roughly the same size bridge occurring, and if it's roughly the same memory frequency, level 2 cache size, all that kind of stuff, then I wouldn't have a big concern between the two. But what I would say is this. If I'm using an R and I have a decent mix of the workload and I am at my 8x number, my magic 8x number, there's another thing that happens with memory, specifically with 8x nodes. When you are on an 8x node, you are guaranteed that your VM is pinned to a certain core and is pinned to the DIMMs, or the NUMA zone, that is attached to that core. And so you are guaranteed a much more consistent hypervisor responsiveness from the underlying hardware. And so in your kind of case, if I could bump up the size of the R instance for the same price of the M instance, I wouldn't have as much memory, but I would have more guaranteed and consistent throughput to my memory channels. I would probably go with the more consistent throughput, because at least that way I have a more predictable behavior in my system.
When I was working with a system that was sharding, the M instance is going to be much lower performance than when I was not working with sharding with these.
What version were you on? Well, so what she was saying is that she found M's were better when she was sharding versus not when she was sharding. And so my question is, what version were we on? Okay, so in 4.4, I believe the split chunk was still being done on the Mongo S, not on the Mongo D yet. Is that right? Or was that 4.2 that changed? So in that case, yeah, so if the split is occurring on the Mongo D, then having more CPU power would be more important. And it would be unpredictable, because when is a split going to occur? How do you, it could be frequent, it could be infrequent, it's going to be depending on very much on not just your design of your structure of your system, but also on just what is marketing sent emails to people on that week? Like what is my user flow coming in that week on what those splits could be? And so if you don't have a separate layer that was doing those splits and you're doing those splits on the machine, or you're doing balancing actions on the machine, then yes, CPU can become a more important thing because Mongo tracks more threads to do different jobs and functions and stuff that could become important. But generally speaking, I never measured a huge difference between M's and R's. I did between C's and R's. But again, I'm trying to think back if I've ever benchmarked that. I'm not sure that I have ever benchmarked that.
Actually, we'll wait till the 3 minutes.
Okay. All right, so I'm going to go through this next part fairly quickly because it's a refresher. I don't know where everybody's at with sharding. So what is sharding? It's the scaling out versus up kind of concept. Fault tolerance, it's limited risk ranges potentially as well, because if only 25% of my users are on a shard because I have 4 shards, then if that shard goes really, really south, I could do some surgery on the config map and make those 75% of the other people start working again, even if that other shard was completely toast and it was going to take me a good while to rebuild it. There's things that I could do. I'm not going to talk about them in the session because they're naughty, naughty things. And I have, like, recently Mongo added the ability to reshard online. The way they do that is not awesome, in my opinion. But I have been resharding customers in Mongo since 2.0. Online, 0 outage. There are ways to do it, but you have to really, really understand chunks and balancing actions and stuff like that. And I am going to cover more on that stuff a little bit later. But still, the point is, sharding is useful for balancing these resources and stuff like that, and doing fault tolerance and redundancy to a certain degree. It helps. But the main reason for sharding for me is so that we have the ability to keep to commodity size hardware and not enterprise size hardware. And what I mean by this is you should never exceed an 8x machine, in my opinion, in AWS for Mongo. Whereas I've seen MySQL machines that are on 32x kit. And like fully dedicated to that machine and nothing else can run on that machine. I've seen that. And that's not completely uncommon. I don't necessarily think it's a great idea because I don't think MySQL can leverage those cores effectively, but sometimes it needs it for memory processing and CPU signaling reasons that people run into. Usually it's OLAP kind of concerns.
This is the form, but that's very untrue.
Huh?
It's very untrue, so you get to your memory sizes and voice curves.
Yeah. Well, I mean, it's just one of those things that MySQL's gotten better, but it's been a slow ramp up of getting better and better at cores. Mongo, similarly, has gone on this journey. It's just taken the journey a lot faster. When they bought in WiredTiger, they bought in a lot of experience to scale up cores faster by who they hired. So when to shard, when we need better performance, we need more write scopes. This is specifically true when we're talking about in-memory engines, for example. Like if I do have that collection level lock, sharding is a way that I can make myself have more of those locks for those in-memories. But also, like, you should, if possible, understand your model enough early in the development process to pick a shard key from the beginning. If you've done that, your life will be better. Can't always do that. You don't know how things are going to evolve. But I would much rather be duplicating a collection and then migrating data to it than having the pain of not having planned to shard a thing that just exploded and having to figure that out on the fly. I'd rather at least have a hash shard key so I could do something to maintain the system's integrity in a sudden use case spike of that feature. Different use cases, I talked about that before, where you have different data or you have different applications all sharing one Mongo cluster. You might shard based on those application workloads so that they're a bit more segmented from each other to where they can all have one interface, but under the hood, they have more dedicated resources to each thing. And we'll talk about a little more about that. So out versus up, again, based on comments I've had in this, I don't think we need to spend too much time on that. I think everybody understands that basic concept. Polyglot persistence, the only thing here is before you shard, ask yourself, should I still be using Mongo for this? Because it might be that the reason we need a shard is we've approached this incorrectly. And the problem needs a more rich data store ecosystem. Maybe it doesn't. Maybe Mongo makes sense for everything. I'm just saying, ask the question before you shard, because sharding is useful and it's good. But if we're separating workloads, like those different microservices or something like that there, it would be a good question to go, should my microservice use DynamoDB as opposed to Mongo, because it doesn't need to richly query the key, and it's only going to do a very specific high cardinality query of a very specific key. Get that back. That's my user's entire payload that I need. DynamoDB is great for that, but it's not great if it's getting rapid changes or structural changes or rich querying needs for secondary indexes and stuff like that. And so that's what I mean by questioning that, because as good as Mongo is, DynamoDB will always beat it if it's being used just as a simple key val storage mechanism. Like, there's no way to beat the parallelism of DynamoDB in that regard. All right, so how to shard. We've gone through replica set there. This is a sharded setup. We've all seen that as well. So the general things that I like to say here is, you could go in and you could just hash shard by default. But I'm pretty sure your development organization is going to come yell at you at some point because they're going to be tired of scatter gathers and performance implications that they're running into from those, or the fact that you are yelling at them because they're not indexing on those scatter gathers and your Mongo S layer is losing its ever-loving mind, or even your systems like are running into issues because of the design of that. And so we should be talking to them early on and educating the developer organization on, no, you don't have a strict schema in Mongo, but if you help me work with you, I can tell you what a good base schema might be for your system, and then I can help optimize the underlying infrastructure based on the things that we do know, and still give you the flexibility for the things that might change. The selection of a shard key and reviewing query patterns, all super fun things. I've written tools to do this. If you look at Percona Toolkit, there's a fingerprinter tool, which they use for a query analyzer, that takes these query profiles and it turns them into an abstract pattern that you could also use to tell you, I have this collection, 80% of my queries on this collection happened in this way. I now know what my shard key probably should be, because that's my 80% case. Yeah, so I wrote the original fingerprinter, and I wrote it because, why did I write it? I wrote the fingerprinter for the consulting arm of Percona to do analysis of customer stuff. Then we ported it into Go, and we brought it into PMM when PMM launched as well. And obviously it's changed over time and all of that kind of thing. But in the same way, like if you go back and you look at Percona consistent backup, that is based on a Python tool myself and another person that I brought over from EA built together, that actually it took backups, it looked at where the oplog was, and it got all of the oplog pieces to a consistent state so that you had a truly consistent sharded backup. Because unless you were using Ops Manager That used to be a very impossible task. And so I've done stuff like that. So this part here where I'm talking about disabling the balancer, enable sharding, shard the collection, add the shards, and re-enable the balancer. Does anybody know why I do that a lot of times? The reason I do that is when you shard a collection, it's going to try to create an estimated initial number of chunks. You can sometimes give it a number of chunks you want, but I find that I like, when I'm sharding, to actually pre-build the map myself and then distribute that map across all the nodes that I want. Because if I know I'm using a multi-tenant structure, number initial chunks isn't going to understand that. I'm going to know what I'm about to shard. I'm going to have a better idea of what hotness I want to start with from a balancing perspective. And so that's why I do that. You can use, when you use the enable sharding, there is the num initial chunks when you're sharding that collection that you could say, give me 6,000 chunks to begin with. The problem with this is if you're doing that and you don't know what that distribution is going to be, you could end up with a shard that has 0 documents in the chunks that got generated. And so what sometimes I will do in this type of stuff is I will actually take my number of shards and I will create, let's say I have 6 shards. I will create 6 keys and I will then do my insert as rapidly as possible into that and let it split inside of that shard. Then I enable the balancer and then it fixes any imbalance that happened across that. And I loaded my data much faster as well. Because instead of starting with something where I might have pinned my inserts onto one node at a time because of the way whatever the data was that was coming in, if I already have that split, I can do some stuff. Same thing with I do different things with batching and stuff like that when I do those initial loads of data. If it's an existing data set that I understand and it's not just a brand new product that's going to grow organically, I'll do stuff like this. If it's a brand new product, num initial chunks is probably good enough. But I guess my question is, do you even need that or any of this at this point? Any of the lower points. Because if it's a brand new product, try to pick the shard key, look at the queries that you're probably going to run against it, but you probably only have one shard. So you probably don't need to worry about what those ranges are, what those splits are, because as the product gets use, it's going to grow into its sharding. Probably, maybe. Some simple commands. I wanted to do a lab, but we only had 3 hours. And also I had been quite sick the last few months. I was at KubeCon, got a respiratory infection that was followed up by a throat bacterial infection. It's terrible. So for 3 weeks I was out of it, not building anything for Percona Live. But, so this is, some basic commands that I put in here that were based on some previous stuff that I've done as well, so that you get a good idea of how I would rapidly build a quick, dirty test environment on my own laptop. Today I do a lot more stuff with Terraform than I previously had, but I can't share any of that, unfortunately. So I wish I could share some of the provider stuff that I've built for Mongo, building clusters and stuff like that. But I was told by our security team that was too much of a concern for somebody to use it as an entry vector into our system. So, such is life. Some other commands for starting Mongo S's and adding shards is that simple kind of stuff. I don't want to get too fancy with those commands. I do say that if you want an easier time building a cluster, check out that Compose. It does a pretty good job. Huh? A long time ago I looked at it, but I haven't looked at it in 3 years. It was okay at the time. It kind of did its job, but at the time I looked at it last, Steny and some of the other guys were being asked to port it to only do Atlas commands. And I think they backed off from that, so I kind of like took it out of my repertoire of stuff I was looking at, because a lot of the Mongo tools were trying to be refocused into pushing people into Atlas, because I don't know how many of y'all have enterprise contracts with Mongo, but if you do, you know they push very, very hard to get people off of on-prem licensing or even AWS on-prem licensing and onto their stack. I have some violent aversions to their stack because of data sovereignty issues. Like, I don't like the idea that my data has to be copied into their account. I would rather them run systems and me grant them access to administer those systems, but the data stays within my company's perimeter. Different people have different views on that, but I have a pretty strong view on that's how you have data leaks that you don't know are coming.
So follow up on the launch part, we've been really happily using it for the last like 2 years.
Oh, okay.
Like developer laptop stuff, I'm like, I have to test how this internal tool that we're building works against the sharding cluster on like the operational side of things. It's been really nice for like quick spin-ups.
Yeah, and I guess we're
Shards you want or Mongos you want.
yeah, and kind of where I've gone with that is because we are so heavily invested in Kubernetes and Terraform, we've kind of gone into where we're building developer containers rapidly as opposed to local iterations. And so that's kind of why I've not really looked at mLaunch as well, as we're trying to, at least in my current role and my previous role, we were trying to get to the point that there was a clear abstraction difference between where a developer programs and the infrastructure that enables them to test. Because then you spend a lot less time troubleshooting what went wrong with local CI/CD. Yeah, and so it depends on the team and the structure and stuff like that. But in both of the organizations that I'm talking about here, there were many, many, many products all sharing kind of monolithic infrastructures. And so it made more sense to fix it at a hosted level than at a local level. Because like, I have developers that come to me in my current role and they're like, hey, I need a copy of this monolith database's prod. And I'm like, that's a 16 terabyte database. No, you don't get a duplicate copy of that in prod. Even if I could scrub the data, I'm not giving you a 16 terabyte database to play with. Like, that's way too much money. Why do you need X? And so we do a lot of that stuff. Oh yeah, absolutely. And I believe they're also recording the session as well, so we can obviously talk to Percona about how attendees of tutorials can get access to that. So I was going to go through a few more of, let's see, where are we at? Okay. A few more of these kinds of topics as far as overview and general processes and shard key type super fun stuff. But I think I kind of all covered most of that. So this was something that this slide and the next slide are actually from a previous tutorial I did a few years ago, but I kept it because I did it with Kimberly Wilkins, who's kind of the head of Mongo at Percona now. She also worked with me at Electronic Arts. She worked with me at Object Rocket. So I know her quite well. We're good friends. But we did this one because what we wanted to do is show the way you can look at these different setups and the performance of them in general with everything being hashed. So we're not doing any special stuff here. And it's this kind of stuff. And another reason I said I was going to share these because it's way too much data for y'all to digest in one sitting. But the idea is we did different things where we were taking different sizes and throughputs and stuff like that to kind of figure out what we could do with different sharding profile types. Because what we were doing at Object Rocket when we were looking at a lot of this stuff, even before we made this slide a long time ago, is we were trying to figure out, well, what plans do we want to offer as a sharded database as a service, high performance platform, and how do we want to help enable people but not give them too many choices or too few choices, all of that kind of stuff. And that's where a lot of this data came from. And it helps talk, and this bottom line is what I like to draw people to the most, is when you have a large number of small shards, the balancer works fantastic. When you have a medium number of shards, it takes a while to get there, as I kind of talked about with different strategies I have for loading the config map myself rather than letting it auto build. It will get there, it'll get balanced. You might need to do some splitting and other stuff over time, but it'll get there. But if you have a small number of large shards, I can almost guarantee you one of those shards is going to be working 25% harder than the other ones. And a lot of it comes down to Mongo balances on a collections number of chunks, not necessarily all the chunks. And so what you could end up with in a system is you could end up with small collections that are so small that they don't effectively shard. And then you have some large collections that do effectively shard. But what ends up happening is wherever those collections, whatever database those collections happen to be in is what shard they're going to default to. And so if I have a couple different databases and a couple different shards, I could easily have a whole bunch of chunks and a whole bunch of imbalance because of unshardable smallish collections, like hundreds or thousands of them, causing too much weight on a shard and not being able to properly understand that. And in fact, to that point, when I was at Object Rocket, I had done a prototype tool where we had thought about disabling the Mongo balancer completely and actually doing our own thing to create a smarter balancing system. We never ended up implementing it because they started doing some other stuff that made it a little bit better, and there were some tools that made things better. But if you want to look at some interesting history around some of this type of stuff, there is a tool called orphan.py that used to be in the Object Rocket folders. I don't know if it still is. And before that, there was something called Orphanage. And it was literally me showing Mongo how I could find orphan documents that would show up in read preference-based reads. Yeah, and so like a long time ago, I wrote a tool that would find and do that. And also, like, if you look online, there's a talk I gave that used a chunk splitter and a chunk hunter that did the inverse of that would find jumbo chunks and split those and all of that. But we'll talk about that here in a minute. And so bad shard keys. This was just kind of an example we used here on bad shard keys. So bad shard keys aren't inherently bad, but your user distribution might be bad. And I'm going to talk about here in a second the multi-tenant pattern that I wanted to talk about earlier that talks about how I think about solving some of these problems. But this is a good example of, it sounds like a good idea to separate based on social media platform. But then you look at those numbers and you're like, oh, well, crap, that's not going to work too well. If I have 3 shards, then I guarantee that I'm going to be somewhere in the neighborhood of a 25% range of variation based on those different social medias. When it tries to balance those, it's going to get to a point. But more importantly, you're probably going to run into cases where, unless you have properly planned secondary parts to your shard key, you're not going to split those chunks. You're going to end up with the jumbos we're going to talk about. And if you've done other things like adding a date or an object ID or something like that to the latter part of your shard key, you'll create other problems for yourself. And so it kind of is a no-win, but we can eventually get there. So the bad shard keys cause all of these types of problems we all know about. Some of these we can fix today. Some of these Mongo has gotten better with their balancer and their splitting strategy. If you don't know, Mongo used to split based on MongoS. So as the writes came into a MongoS, it would keep tally of how many writes were going into a chunk. And if it crossed a certain threshold, it would trigger a split chunk on that chunk. But if the MongoS was restarted, that data was lost. Or if you had 20 MongoS's, it was distributed across so many places, it might not get split in a reasonable amount of time. They fixed that, they moved it into the MongoDB layer and the config server layer, and so that's a lot better. But we still have this problem where we're not based on hotness necessarily for our balancing, we're not based on storage. We don't, as DBA professionals, DBRE professionals, whatever your chosen title is at the moment, have a control mechanism to choose the best strategy. And I would really, and I have since Mongo 2, really wanted to see that in Mongo. But the argument has always been there shouldn't need to be a lever, it should figure it out automatically. And I'm like, we're talking about big systems. If we're talking about sharding, maybe we should have a couple levers there. But yeah, so that's kind of that. So sharding patterns, the main ones that I kind of focus in on are the tiered, the geo-sharding, and the multi-tenant. So the tiered is kind of what I was talking about earlier, where I might run a primary shard in memory, operates as a cache, but it has a hidden replica running WiredTiger with persistence for syncing down to disk. Again, this isn't to say that I can always recover or I'm guaranteeing to my teams that I can always recover. This is just saying, hey, I'm gonna do my best that if we have a full crash, that I can bring back some of this cache data, but I'm not gonna be able to guarantee I'm gonna bring back all of it. Now, the chances that I'm gonna have a full crash of that shard means that I'm gonna have the majority of my nodes fail, and I'm gonna have to restart them from that persistent node. And they're gonna have to suck all the data from the persistent node and load themselves up. And so it'd be in a pretty bad situation if I actually needed that persistence layer. I just like having it there for insurance, kind of like with the snapshots. I'm a pessimistic person by nature. But this is really good for if you have certain data in that you want to point to that primary shard, such as session data or stuff like that, that is more transient in nature. And then your secondary shard is what I kind of consider my normal shard, which is where a lot of my general purpose stuff goes in. You'll notice I'm talking about, it's normally, WiredTiger, it could be IO2 POPs, it could be GP3. This depends on some of your strategy in your company as far as how valuable the data in that secondary shard is, or if I even need a secondary shard. Maybe what is currently listed as a tertiary shard is the only 2 shard groups that I need. I could only need GP3, or I might have an ultra high performance need for something. But the whole idea behind this pattern is I can have different levels of resiliency and loss that occur in my system. And the thing that I did want to talk about here is if you're using it as data ages, you have to keep in mind of this little tidbit in Mongo, and that is you can't change the shard key. It's an immutable value. And so I can change ranges on my shard key, and I could cause those to go to different shards. But it could be quite hard, and I might need to export and re-import certain data if I'm trying to forcibly move a specific set of data from one level to another. And so just keep in mind that, and also just how valuable is data to your organization as it ages. This is a battle that I will probably have until the day I die with different teams, where getting them to recognize that copying the same bit of data into 8 places in the organization costs money, and it's a thing that we have to consider. Or even, why do we still have this in our primary data store? Why is this not in a historical data store? Why is this not on some sort of historical shard with lower tier storage that's using ST1 or something else? These are options for this tiered approach, depending on where your data value is and all of that kind of stuff. And And so like these were just the primary, secondary, and tertiary were an example of a high, a highest, a high, and a normal kind of access pattern, but riff on that. It's a good pattern to just think about when you're building your tiers, not your tiers, your tiers. An example of the locality pattern would be more like this. And so this might be a case where what I actually want is I want a collection that keeps US data in the US, and I keep EU data in the EU, and I have a general bucket for everything else. As you can see, the rules with shard keys ranges are complicated. Because I can't just say EU goes to this shard. I need to provide a min and a max key. And so what I need to do is I need to say the inclusive range of the max key before the U of EU goes somewhere else, or the different names of the countries in the EU, depending on how you do it, can get quite complicated. And so the important things here that I wanted to point out to people is use min key and max key. Don't try to figure out the numbers yourself. Just use min and max key. It'll figure out if it's a string or it's a number or whatnot. It'll help you a lot. Use that, but then you can plan on different ranges like this. You could obviously create a much bigger, more exhaustive list of countries as well. You can do like what I did here with the US, where I said country equals US, blah, blah, blah. You can do that. And one of the things that if I was doing something like this, what I might do is expanding upon this pattern, I might have two shards that are tagged as US, one in East, one in West, and then I might have my replica sets across those, or have one shard in each case, and maybe my user IDs are built with a prefix of some sort where I know everybody whose default is US East versus their default is US West, and I could delete and re-enter that user if I wanted to move them between the EU and the US, or the EU and somewhere else. And the multi-tenant pattern is the big one. This is one where if you have big customers and a few big customers and you have some small customers, or you want to rebalance hot users, you need to do this. It uses the same replica set tags and zones that we've said, and you might use a tenant ID to do those types of ranges I did. But it's one of those things that if I am using a hash shard key, I might be able, based on my tenant ID, have that as the prefix to my hash shard key, so that I could then take that range and say anybody that belongs between this maximal value of the tenant prefix and this maximal value of this minimal and maximal value of the tenant prefix, if they're in this range, send them to my special customer shards. If they're not in this range, send them to general population shard. And that's a really good way to keep big customers from evicting small customers from your caches and other things. But it's also a way to get into a place that you are better aligning your quality of service to how much that customer might pay you as well. Because it might be that I throw much bigger or faster gear at those big customers because they're valuable enough. Or products, if you're not talking about being an MSP, products inside of your organization that might be more important. Like, it's probably much more important at Udemy. We don't use Mongo for that exact case, but for Udemy, it's probably much more important that somebody can look at courses and buy access to courses than it is that they can see their progress in any course they've done. Like, just as a function of business, there's probably a quality of service between these different services within that single application, single website, that you want to prioritize certain behaviors over others. Or like, what is the value of the recommendations engine versus the search engine? You know, stuff like that. all play into this kind of thing. But I would say the other thing here is, in my experience, I have done a lot of stuff by recreating a hash shard key as a compound key for these types of multi-tenant setups. So that I can start with the prefix of a tenant ID and then have what equates to the same thing as a hash shard key as a key here. But it's more work, it's more effort, probably a whole talk just on how to do that. So deduplication and field names in Mongo. We've kind of talked about that. Does anybody have any questions on what I was meaning by the compression doesn't work on memory and in transit and all that kind of stuff? Or does that make sense? Because it's very different than the line Mongo gives people. Mongo gives people a very clear line of, well, why would you ever use FN? Just use first name. It's a magnitudely more expensive prefix that's going to now be stored in every document. And I believe I have, here we're about to get into some of the settings. And I'll talk about some of those and how those play specifically with that pattern. But the implications are, it is still 5 times the space to store first name instead of FN. And so any place you can get that savings, it's going to pay leaps and bounds, especially in AWS. Because a lot of people don't realize in AWS, I'm paying bandwidth when I go between my application and my database. I'm paying bandwidth when I'm going between AZs for replication. Anything I can do to reduce that is going to save on my AWS bill. And bandwidth is the sneaky thing that will come up with S3 and bandwidth are probably the 2 sneakiest things that will come up on your AWS bill, and they be very hard to attribute to where it came from. All right, so that's that. So these are some WiredTiger options that I like to go through, generally speaking. So like the cache size, some maximum memory that's allocated. Depending on what you're doing in your system, it might be useful to have this bigger. If you're in a write optimized system, focus on CPU. Don't use a ton of cache. Use enough cache so that you're not checkpointing constantly, but don't go overboard with your cache. Don't go to the full 60% with your cache sizing. Go leaner on it. Because if you're not doing reads, what is the value of this cache? Like, if that is not your main pattern, what is the value of it? It's just wasted resources effectively because it's inserted into that cache, it's never read, it's then evicted as it ages out. It provided nothing for us in the end. But for read-centric systems, it matters a lot. It helps a lot. And so optimize for that, but don't optimize for it to the point that you start swapping, please. Please, don't swap. Evictions are kind of the same kind of thing here. You can control the frequency of evictions and how those behave with this setting. I talk more about some of these settings in the session tomorrow, I think it is. But what I would say is, if you are doing a bulk load in Mongo, even if you're sharded, consider adjusting your eviction setting while you're doing that. Because you will be better off doing fast evictions, lots of smaller fast evictions, than large evictions, as far as getting that data loaded into your system and minimizing that window of impacted or degraded behavior. The other one is statistics log delay. So who's ever looked at WiredTiger statistics? Yeah, so that's kind of one of my points there. It's really useful if you look at them, but if you don't look at them tune it down. Let you use those resources somewhere else, because they are really great for determining why something could and how something could be optimized. But most people in Mongo have never looked at a lot of the different metadata and statistics available.
Would it never make sense if you're doing a bulk load to just turn off the evictions temporarily? Like if you don't know you're gonna need that new data anytime soon, and you've got that extra overhead in the whole evictions process.
But the problem is to write the data to the data file, it has to be loaded into the cache, and then it has to be checkpointed, and then it has to be written to the. And so the problem is if I turn off evictions, that just means I'm turning on the OOM killer. But that said, between checkpoints, which is another setting I'm going to talk about here in a second, and that, there might be tunings that you do to better optimize for the fact that I know I am doing lots of rapid activity instead of general activity in the system. Because I might do certain things to delay my checkpointing so that I optimize my write speed from an IOPS perspective. Like that might be a balance point I have. It's very circumstantial and hard to say in a generic way, but you'd have to look at the system, but there are cases you would do that. So the block compressor, this is where compression matters. So if you increase the size of the compressor, it has more data it can look at, more documents that it can cross over, and therefore a higher chance of figuring out what is duplicated data and dedupe it. The downside of it is you're going to use more CPU, as we were talking about earlier with instance types. And so it's a balance point. It's also something to keep in mind is in Mongo, it stores the compressed version of a block in the cache as well as the uncompressed version. So the larger you make this, the larger both of those get when that happens. And so you have to just be a little careful on what you're doing with that compressor size, because you could have unintended consequences as far as like what's needing to be evicted and other things from a memory perspective. It's not to say that large block sizes are bad, but you probably don't want to set it to like, I don't know, like a gig. That would probably be a really terrible idea. But, but it is something to play with, and it can drastically affect the compression level on disk. So if your company is really concerned with never deleting anything, storing it, but keeping it in a cold state on your Mongo instances, playing with this setting to maximize your compressibility ratio is a very good thing to look at.
Modifiable on the fly, or is it when creating a collection like some of the others that you're going to do later?
I'm pretty sure this one is on, it's on creation or on engine startup. So if you were to tune it and restart it, then any new documents would get the new compressor, I believe. Any new blocks would get the new compressor size. And what would happen is if like, let's say I moved from 16 to 32, I believe what would happen is if you change the setting and started the instance back up, then the next time you read that 16K block, it would then recompress that into the 32 the next time it read it. But that's not one I've tested thoroughly, so I'm not 100% sure, because generally when I've been playing with compression, I've been just rebuilding the whole node at a new compression level and just letting it do a sync. And so I've never tried to do it in line.
So you'll start it up with the new settings that you want, the clean slate.
Yeah.
And have it pulled in.
Yeah, because a lot of times for a lot of these settings, what I do is I set it at the engine level, and then I do a resync, and then it just populates all my data files and everything that it's doing with those values. And then I just kind of musical chair my replica set until they're all back in a consistent mode. But in that way, I don't worry about transitional states. that I'm not sure how it's going to behave, and so I would rather just not let it behave that way than to run the risk of finding out what that behavior is. The max leaf page size is an interesting one, but I'm debating. It is good to increase this, and it is good as far as allowing B tree rebalances to be a bit healthier. This is a very, very rare setting for me to change. Like, I usually have a very specific indexing problem with where people are doing lots of updates to a user document that's rapidly evolving and changing for me to change this setting. But that said, you could have a write heavy true shard and a write heavy false shard, like I was saying here, and have different modes of this setting so that I'm optimizing for my ingestion rate. But again, then it gets into questions of, well, how do I then move it out of write heavy over time? Is an interesting question. So the logging subsystem, there's several different options to this specific setting. The only thing I really was kind of coming here is, depending on what you're doing and the checkpoint log and stuff like that you might need, the journaling and stuff like that you might need, you might want to tune this setting if you're having certain performance characteristics. It's best to go to the WiredTiger engine documentation and read about this setting, because there's a lot. There's a lot of considerations to make, and if you tune it or you turn off logging to turn off durability for like bulk loads and stuff like that, there's a trade-off. You can do it. I'm not saying not to do it. I'm just saying be sure you know what you're doing. Just be very, very careful, because if you have turned off this logging and you're doing a bulk load and something goes wrong with the storage layer, and you've done this across all your nodes of your replica set, you might have just trashed that whole shard. And so did you build a proper contingency plan for that to occur as part of your bulk load process? And similarly to logging, you have checkpointing. And this says how frequently it does checkpoints. It's not unlike MySQL and other technologies in their checkpointing. But what I would say is, if you need to get a little more TPS, tune down the checkpointing a little bit and rely more on the redundancy you've built into your replica set. Could be a good thing. This is a setting that I normally play more when I'm doing bulk loading. I would play with checkpoint before I would play with turning off logging, because then I'm delaying some of those checkpoint processes so that I'm creating fewer maintenance IOPS and more data IOPS, if that makes sense to everybody. I don't usually play with that one too much. Sync is kind of in that same kind of thing. You could disable certain sync processes while you're doing bulk loading, which I do recommend if you're doing bulk loading, so that it will still sync on its periodic basis. It just doesn't force the sync as frequently as you might want to do during normal occurrence. Because more than likely, if I was doing a bulk load in my system, I've probably taken some sort of maintenance and warned people about performance implications and stuff like that. So I might be okay with syncing 1/20th of the ratio I normally do to get that extra load time so that my impact window is a smaller time window. And so this is kind of what I meant by eviction, sync, checkpoint. They all play very tightly together. And so I think it's more important that you know that these exist, because if you look at the Mongo documentation, they don't talk at all about some of these. Like, as if they never existed. But they're in the engine. We can use them. They are cool. We already talked about the write-in-memory stuff. I probably should have just removed that, but I think I kept it here because it was still an option. I think is why I kept that slide, even though I duplicated it. So cursor semantics. I'm going to be light on this a bit. I didn't go into too much detail on it, but I was just kind of talking about what a cursor was. One of the things I wanted to point out more specifically in cursors is, I think we all know what a cursor is with databases and programming. I don't think we need to get into detail. The lazy evaluation of cursor batches in Mongo is an interesting thing. When you do a find, let's say you're getting back 10,000 records. Did you know there's a difference between the first 100 and all the rest in what it does? Because if you've ever actually paid attention, when you go to do a query in Mongo, the first 100 records are going to come back lightning fast. But then when I go to get the next set, I have a long pause. And you're like, well, why did that happen? What's happening there is actually it has a bigger range of documents that it will find or a certain number of megabytes. And so what I do is if I know that I'm gonna have a cursor that's gonna be reading something and it's gonna be more continuous and it's not just a pagination thing on a web page display kind of thing, then I will set my batch size by default, which overrides that default behavior and gives me a more consistent cursor iteration process. No, but it always does 100 by default. And then the secondary batch sizes are based on either a number of documents or a megabytes per second. But when you set batch cursor size, you say, always give me 500. And so I always get that consistent behavior. And so for most web applications, you wouldn't set this because they're probably using pagination. But for a lot of like pulls down to data feeds and syncing to your data lake or whatnot, that's an important thing some people might need to understand. Or if you have certain sort behaviors that are occurring, it could be really important to understand. Because if you're going through a MongoS and you're doing a scatter gather and it's doing a sort, depending on what's going on there, that cursor batch size could be the difference between an idle connection timeout getting killed at some sort of networking level and not. Because, or like, this query worked at first, but then when I tried to get the next part of the batch, I started getting timeouts. Like people will have those types of weird issues in their application sometimes, and it's down to that batch cursor size. Driver semantics. This was just really talking about how the drivers facilitate communication, and it's a way of creating a consistent behavior around all of the languages. Now that we're in the 5.0 and 6.0 world, it's even more important because now we're starting to talk about backward compatibility driver semantics, where in 6.2, you'll be able to say, pretend like you're 6.0, and it will talk to a 6.0 driver as if it was 6.0, removing a lot of the forced upgrades of drivers that we've all had to deal with in the past, where it's like pulling teeth sometimes to get developers to upgrade the Mongo driver, even though if they don't do that, the code's not going to work if I upgraded Mongo. Like, I've run into that quite a bit with teams, and I'm really excited about that feature, and that they're trying to do more future planning with the semantics and backward compatibility. I'm also leery if they're going to abandon it a couple years later, realizing just how complicated that maintaining that behavior can get. But we'll see. Transactions. I was at lunch. Somebody was making a joke about Mongo, and he said, I forget exactly how it went, but it was something about Mongo and MySQL were dating. MySQL wanted to get married, but Mongo just couldn't commit. So it's kind of funny, but it is kind of true. I am not sure how I feel about when MongoDB Inc. says something is ACID. Because on one part, I can get the very pedantic definition they're using to get to say the statement they want to say, but it's not what we mean by ACID. It's not what they understood when you're referring to ACID as a concept. But there are transactions. They are in Mongo. The logical clock stuff can get quite complicated, especially when we start talking about not just sessions, but transactions and apply orders and stuff like that. I generally advise people avoid sessions and avoid transactions in Mongo. It sounds cool, it's an interesting feature, it's nice that they added it, but if you don't turn on those and use those bells and whistles, your life's going to be better in your Mongo world. Your developers' lives are going to be better. There's going to be far less confusion of people trying to figure out what went wrong. I think a couple more years, it'll mature a bit more, and I might change my tune on that, but why am I using a document store if I need transactions? That's my underlying question. I probably need to think about my architecture of my stack a bit more on why and how I got to that point. Session, yeah. And I mean, causal consistency is an interesting concept. When I was at Percona, I gave a lot of training on it, and I had a lot of really confused eyes looking back at me, even from Perconians, because if you understand temporal transaction mechanics, it makes sense. If you don't, it doesn't. There is no middle ground. Like it's, it's just one of those things. I will say that the more you understand how Git works, the easier causal consistency is to grasp, because it's really kind of the same logic. But the number of people that I work with and I am asked to go repair a branch because they can't figure out what they did to it in Git is sometimes disheartening. Because I wish more people understood why the branch was erroring, why Mongo's causal consistency was behaving this way versus that way. I wish it was easier for people to grasp. So best practices, we kind of talked about the bash behavior. Connection management, use connection pooling in the Mongo drivers. Don't try to use load balancers to get smart there. It's just going to be painful. But do use connection reuse in those connection pools and try not to kill off connections you don't need to kill off, because we're all using TLS, right? Everybody's on TLS 1.3. Like everybody has TLS turned on for intranode communication and X509 keys for authentication, right? But in reality, like I try to plan everything that I'm doing with that expectation as far as connection planning and stuff like that with teams, so that later at some point when a security team comes to me and says, hey, this system's now under this compliance level, you'll have to be TLS everywhere. It's not a shock to everybody's system. We've planned for it from a design pattern. Error handling and retry strategies. I see a lot of times where I have to remind devs, just retry it, just retry it, just run it again. If it failed, just do it again. Maybe that's unique to the organizations I've worked with, but I feel like not enough people have embraced the cloud is not guaranteed, and there will be problems, and there will be issues, and you need to build for it. Recently, we had an incident in a company that I help, not at Udemy, but a company that I help, where their entire stack was offline for a greater part of, I won't say how long, but for a very long time, because they failed to build a plan for what happens if an AWS node refuses to shut down. There's not a lot you can do. there's not a lot AWS can do unless you manage to escalate to the right people at the right time. Sometimes you just have to wait it out and try force terminate 12 times and then it works. But these are all things that we need to plan for, and Mongo is built for this, but I see a lot of people not building tools to leverage those abilities. So sharding considerations, we kind of talked about the affinity type of stuff that I was talking about earlier, where if you go to the right MongoS, you will get that affinity, you will go to the right place. If you don't go to the right MongoS, well, all bets are off. Distributed transactions, this is why I don't like transactions, just avoid them, just don't do it, just don't do it. If you can avoid ordering a scatter gather and ordering it instead in the application containers or application servers, whatever you have, your life's going to be better. You really should try to do that. I wish Mongo was better at scatter gather order by, but it's not. I wish there was a lot of things that were different around the MongoS layer. And I wish it would mature more because it hasn't really changed in several years now. They built it, stayed, it's kind of what it is.
Do you have advice around metrics for monitoring that kind of stuff? Or the places that you work had to custom implement their own sort of like shadow traffic and reporting using explains for some proportion subset of data?
Have you looked at the Mongo exporter for Prometheus that Percona has? Because I put because I did, when we originally built that, I did put in some of those metrics to get tracked there. That helps with it, but a lot of them are metrics that show that it happened, not metrics that will help show what the memory pressure.
Is it when it's MongoDB exporter against the MongoS?
Yeah, so it's the Mongo exporter, when it hits a MongoS, will...
Disable those because of a rogue query and very large clusters.
Okay, yeah. Yeah, and so yeah, like what I tried to do when we built that exporter is I tried to make it to where it would gather intelligent metrics based on the type of thing that it was connecting to. But yeah, I mean,
Maybe we should just patch that one rogue query out of it and then deploy it for ourselves.
that or have you patched it and submitted it to Percona?
No, we can do that.
Because as long as you've signed the contributor thing, I'm pretty sure they would accept it without a lot of fuss, unless...
It's an older version, it might need to be like back for me to backport it in, but I could check.
Yeah, I guess that's the thing, is if it's a current problem in the current release, if you patched it there, then you could potentially do that, and maybe if you've written it cleverly, you'll cherry pick it back down into your level. But I'd have to see the code to really be able to comment on that. But I did try to do some of that stuff. I did try with some of the initial graphs and stuff like that we created for the MongoS and stuff to help expose some of that stuff. But my focus was more on chunk balancing than those scatter gathers. The scatter gathers they work, and it does what it needs to do. It's just whether or not your application is going to wait a long time to get the answers it needs. And so it's less of this is going to break and this is something we can change at a DBRE level. It's more well, this case is occurring. Developers, y'all should probably fix this because this is a direct result of the query pattern that we're running into. Let's talk about the shard key. Maybe we need to reconsider the shard key we're using. Or maybe we need to think about how we query this data slightly differently. But yeah, it's a challenging one. So chunk migrations and read preference. How many people use secondary reads to replicas? And how many people assume that that data is accurate? Not giving me duplicate or orphan data? Yeah, but like that's a legitimate, and that's why I had that one line there under cursor operations and sharding, is that cursor operations, if you're doing read preference secondary reads, you are not guaranteed by Mongo that you are getting a just once answer. So it tries to do stuff. If it is a primary read, it will use the chunk map to filter out things that are currently in a balancing action movement process. If it's on a standby, a secondary, it doesn't have that chunk map available to it. And so it doesn't know that. They talked about adding it. I don't recall if they ever fully added it, because the one implementation I saw where they added it, it worked if you used the word secondary. It didn't work if you used tags. And so I don't know if they ever fixed the second part of that. To be fair, I am spread quite thin on a number of technologies right now, so I haven't been watching their Jira board as much as I used to in previous years. But that was a challenge. That is a risk. Something to watch for. It's not to say that it crops up a lot, but if you have a really weird behavior of why does this show on this page and then not show, you might be hitting that kind of circumstance. So in query routing, designed by your common query patterns. I say this, but your common query pattern might be write as fast as I can and let my reads suffer, depending on the type of system that you have. Because some systems would rather not have a backlog of ingestion rather than necessarily be instantly correct on their consistency model. They might be more flexible on the eventualness of it. And so shard keys are a complicated one, but generally speaking, my rule of thumb with shard keys is optimize for writes first. I can always build more replicas. That's not always the rule I follow, but that's my starting place. I have a lot of kind of principles like that on like, these are the rules for storage engines, these are the rules for picking a shard key, but here's where I break these rules. Because I don't believe in absolutisms, I believe in reasonable and practical defaults. But yeah, so there's that. So let me see where I'm at time-wise. I'm running low, I think. Yeah, we have a little more time. All right, so password hashing in Mongo is actually quite good now. Used to be terrible. Does anybody know in the 2.0 type range how Mongo hashed the password? It's really great. It was the password plus the string of the username plus the hash of the password. And so it doesn't take a lot of computing power to figure out that hash. So they moved to the scram-based hashing in modern versions. And it does do some industry-wide stuff, but the most important thing I wanted to talk about with this is because of the salt and the iterations it uses, it's very, very hard, not impossible, but very, very hard to actually forcibly brute that just by looking at the raw version of it. You could try to brute the system, but then you'd get all your audit log should tell you that somebody was rooting your system, and you should have alerts for that. So, but somebody couldn't just take that hash and hit it enough times to figure out what it was because of the scram design. And so I do like it. It is quite strong.
Is it using like encrypt or Argon 2?
So it's actually, I forget the RFC, but it's using HMAC is the base of it, and then it's there's a specific Scram RFC that they prescribe to that talks about it a lot. I'd have to go find that, but yeah, I haven't looked at it in a while, but they were importing functions from other crypto libraries rather than trying to do it themselves. Is the big thing there, whereas before they tried to do it themselves and it was terrible. Yeah, but I think there's also a version of it that just does SHA. Because I seem to recall that there's an option there for that. But I might be thinking of a different thing for the actual encryption, the encryption part of the WiredTiger engine I could be thinking about. But so Mongo roles, these are a lot of the common roles that I see people using. I am bad, but I still make these. I still make a root one. There are still certain operations I can only do as that, or if I'm being really sneaky, I use __ system, and I use the X509 cert from the cluster auth, and that gives me root as well. But I prefer to use the root one and just grant it to some sort of LDAP or other system for privilege escalation purposes. But the thing I would say is I don't write a lot of custom roles anymore for per collection type stuff. I used to be very adamant about it, but then what I started to realize is the more of those I wrote was just more work my team was having to constantly change and alter because somebody did something different. And so I got into the flow of creating a dev read user or dev write user and just adding resources to it instead of creating separate roles for each collection a dev would have and being very strict about, no, your application can only talk to this collection and use a different credential if you need to talk to this other collection. I've been more relaxed in my recent years on this because I found that if I was being as strict as we should in the Mongo model of having that strict min privilege kind of thing, I ended up with the team spending too much time maintaining that and sacrificing patching and advising the development teams. So your mileage might vary on that, but think about that. Think about how many custom roles you really need and how you might make a generic custom role and just plug resources into that role as opposed to making a fully custom role. So Mongo resources, like I was just talking about there, the any action, all that kind of stuff. You have to specifically call out when you're doing system collection stuff. It's okay, it works. There's a lot to talk about in Mongo users and roles and resources, but be aware of the cluster tag, be aware of the system tag, be aware of the system collection names, because all of those will trip you up. I would say I personally avoid creating users inside of databases. I create them in the admin database with restricted privileges most of the time because I find it's easier to communicate that behavior to developers and they won't forget about it. If I say, oh, you always connect to admin with this username and you'll get this role and it'll give you access to the database you need. I found that that's easier in my experiences. If you agree, cool, If you have a different view, I also respect it. I just got tired of having the same discussion literally 3 times a week with different developer groups, just in a cycle. And then sometimes, like 3 weeks later, I'd repeat myself again to the same person.
So you say connect as admin and then just assume a different role?
Well, I'm saying connect to the admin database where I've created that user that has privileges to that other database. And so you connect to the admin database, and then you switch database contexts to the one that your role has access to. So I'm not giving them admin privileges as much as I'm just creating one interface that they always connect through. And again, it's like Mongo should be able to do the other one. It just confuses people. So a lot of the actions I typically use are these. The second one, I don't know how many of you have used. I don't know how many of y'all are using JSON schema and schema validation stuff. I use it a lot, and this is how I use it. In development, I do not do schema validation. But to promote to production, there is a schema validator updater that then locks the schema in place for production so that somebody can't willy-nilly go in and change production without using that bypass validation role privilege. So that's what I do, because I don't want to restrict developers from having the free form in development to move fast, but I do want to not be surprised by some bug that all of a sudden, instead of saying first name, it says first underscore name in these 5 cases. I would rather those queries error in production because they're violating that schema, because that's not an expected behavior. That's my personal take on that one. The other one is in progress. I find that that's very useful to a lot of drivers, and a lot of frameworks make use of it. And so in the past, I would be more on just, I'm just going to give them find, insert, update, delete, and list collections, list indexes, that kind of stuff. But I started giving in progress more because I found a lot of drivers were asking for it. And then obviously for DBA type people, DBRE type people, list shards, move chunks, split, I like giving to those teams by default, and remind them with power comes responsibility, all that fun stuff. I do not give server status to developers most of the time. And the reason I don't do this is I've gotten burned by this, because they started putting the output of server status into their log files and then not securing those log files. And that was a vector for attack, because now you know the host names, you know the database names, you know the collection names, you know what authentication style is, you know a lot of stuff about how to craft the attack onto that Mongo system. And so what I've done instead is I've provided services for my team that they could hit that would give them a minimized version of server status, so they could see some stuff they might be looking for as far as memory usage and all of that fun stuff, or engine statistics, without exposing some of the more sensitive data. It's in the same way that, like, when I've been a client of MongoDB Inc. before, I've gone round and round and round with them because I would not give their log files back to them until I had scrubbed them, because I didn't want my host names uploaded to their Jira where I didn't know where that file was going to get stored or moved to. Like, it's great that they want that data, and I get why they want that data, but I've argued for a long time that they should be like creating UUID like they do with tables there. But the problem is, in some of their log files, they store the collection name or the database name still, not the UUID. And I'm like, what are you doing? Like, use the feature y'all wrote. And they're like, oh, there's a backlog thing for that. I'm like, well, that doesn't help me right now. I'm not sending this log to you as it is. I have to change this. But yeah, so that's a lot of the stuff that I use by default. I do block most users' access to drop collections and initial sync for obvious reasons. But I do, if I'm not backing the system by LDAP or Kerberos, I do give them changed password sometimes, because sometimes it's easier to let the development teams manage their password rotation than the database team. Just one of those things that you give up sometimes. And so this was kind of an example of what I might do with a super root type role and then grant it to a DBA user. You might do something like that. Nothing special there. That's just the basic syntax of it that I like to have in this. So I'm not going to talk a lot about LDAP. It's complicated, very complicated. It depends very heavily on your LDAP structure as well. One thing I would say is at one of the companies I used to work for, which was an airline, I had to set up my LDAP system to scan the entire LDAP directory because of the way they structured their user groups and their user OUs. I could not craft a query properly that would only scan those things, and I needed to scan the whole tree. And so LDAP is great. LDAP is wonderful. I like it. I don't like having to reset developers' passwords, and I like them inheriting groups based on a group that they're a member of in Active Directory. All of that I love. But I do hate administering LDAP for Mongo because it's getting better. You don't always have to call the muck stuff. There's newer implementations you can use depending on the version you're on. But LDAP queries you can find quite limiting sometimes when you're trying to set up the LDAP to work. So that's the only thing I would really say on LDAP, other than the fact that somebody wants to patch it so that it encrypts the string before it sends it. I would be super happy if I saw that appear in the Mongo ecosystem. Because right now, the driver just sends it plain text. Hopefully you're using TLS. Like, it doesn't even hash it. It doesn't salt it. It does nothing. It's pure plain. That's a duplicate. So I updated this slide from a previous one I had to that just calls out all of the TLS options and then what options the client similarly uses. If possible, try not to use TLS, allow invalid anything. Please don't do that. That it's huge benefits of the system. Instead, use SANs and just stick the DNS names or IP addresses in that SAN list. And that way, at least certificate is valid and you can trust that it behaves the way you expect. One thing about CA files that I will call out is if you are using a Mongo client on a Mac, and if the CA is not working for you and it's saying that it's an invalid host name, invalid certificate, there is a very high chance that what your problem is the CA is valid for too long. Because Mac has a do not trust CA certificates that have a lifespan of, I think it's 5 years, more than 5 years or something like that. They don't trust it by default. And so if you run into those types of weird problems and you find yourself having to use the allow invalid certificates, it's probably where you need to talk to whoever you work with on your team that's building your CA certificates, and for Mongo, get a sub CA built that has a more limited life cycle that you could use. And then that will play better with Mac OS. It's nothing wrong with Mongo itself, but it looks like something's wrong with Mongo. That's all for really that. Who uses aggregation pipelines? What do you use it for?
As little as possible.
Okay, so you actually use it for mini ETLing kind of stuff. Okay, what about you?
Just sometimes customers that I help are using it to help them practice the expression or things like that.
Oh, okay. I've done some really crazy and intense things with it, such as like, when I was at Object Rocket, there's a customer that helped people find what beers were popular in a geolocation that was close to them. I think it was Tapped or something like Untapped, or I can't think of the name of the product. Huh? Untapped, yeah. And the aggregation there was quite complex, and my brain hurt after I figured it out and made it work. But what I was doing is I was getting what were the popular pubs in a region, and then I was pipelining that to find out what were the popular beers in those, and adding those to a set, and making it to where I could say both what were the popular pubs to go to and what were the popular beers at each pub, but also aggregate in your search area what were the most popular beers overall as a roll-up type function. Very painful to do. It's all sorts of ad sets and storing it in a variable off to the side and then reusing it, and crazy stuff that's hard to do. But it is interesting work. It is interesting things to do. I've also used it as ways to summarize certain data with IoT, so that then I could, like, just before the TTL kicked in, it would kick in, summarize that data stored in another place. So kind of ETLing, but it's also more, I'd say, merging of the data, not necessarily ETLing the data. Yeah, and so what I was going to say is the most common ones are match, group, project, and sort. Add to set is a very interesting one that can be used to create kind of a side variable to then use between different stages and stuff, and then you can LM match and do some crazy stuff with it. But generally, I would stick with these and not try to get fancy with the aggregation framework. It is a cool tool. It is useful, but you're going to spend a lot of brain power getting it to do exactly what you want and not what it thinks it's decided that you told it to do. So some additional things, like I was saying, is like unwind, lookup, project, facet, all of that stuff. They're cool, they're fun, they're very specific. Limit is also very useful for short-circuiting certain behaviors so that I can stop scanning as quickly as I get enough results to do something. It can actually be really interesting to use an aggregation framework to update a document version that hasn't been touched recently. So I've run into situations like this so model's been changed and new users or interactions of your system touch the document, update the document to the new version. But then I had to write aggregation frameworks to find documents that hadn't been touched and upgrade them because the app itself had no flow to do that. And so that's interesting cases that you might use, but should be edge cases. In the slide deck that you'll see, I kind of shared through some summary, basic match and group kind of stuff. This one's relatively simple, I think. And then you get into sorting, which starts stacking on the complexity. And then you get into a multi-stage pipeline, which kind of gets you into, okay, now I'm starting to limit, and maybe I'm going to do stuff with the outcome of that. And then you get into this kind of terribleness. And it's nice and it's useful and it does what you're asking it to do, but that is so much harder than just writing the SQL. It is so much harder than SQL. And it's just, I find aggregation unnecessary. Like, I'd much rather just throw the BI connector at it and let let I don't know, a Jasper Reports or a Tableau have fun. So your main index types are, these main ones, we all know them. So index challenges, sorting and batching, we've loosely touched on. Who here has gotten this really fun message from Mongo that's exceeded sort memory size aborting? It's a super fun one. But basically it means it's doing a file sort, not an index, and it only does so much and then it gives up because it doesn't want to consume all the memory on the system. I've had users hitting that enough times at the same time that they tanked my server. Tanked the whole server. Because in that small amount of time, they had 500 queries all trying to use that sort memory at the same time. OOM'd my server out of existence. And then it OOM'd the next server, and the next server, and the whole replica set failed. Because they just kept trying. And so watch very, very carefully for unindexed sorts in your stack. Like that is by far one of the most important metrics to be careful about, because like I said, your app can DDoS you before you have a chance to react if you're doing that. And a lot of times they don't realize they're doing it. Like they never intended it, or it's some new query that has some weird edge case to it. Index building is an interesting one. Who uses background indexes? Why, see if any of y'all can answer this question, would you think that I asked that question? They're interleaved, yes. What else? Yeah, and for a long time, what else? They were not backgrounded when replicated.
And if the server stops in the middle of it, it'll come back on the foreground.
Yep. Well, and also it will stop the server from coming back up fully until the index build that was in process has completed, which is probably the more important thing there, because foreground blocking is annoying, but the fact that it's increased my recovery time objective is the bigger concern. And so I'm not a fan of them, but mostly because of those performance indications and minorly because of the interleaveness. Because the interleaveness, it is bad. It can create some performance characteristics that you don't like, but it's kind of depends on your environment if it's enough to care about that one. Whereas I think everybody cares about the increased recovery time. Intersections, I kind of wanted to talk about that a bit, where Mongo is not the best at unioning different index searches together. So be careful about that. It does some really weird optimizer behavior sometimes where you would have thought a union would have worked well, and it just, for some reason, has way more works than you would have ever thought it would have had. And I've never gotten to the bottom of why that happens, because it seems to kind of come and go when I've tried to test it. Like typical, like you try to add more measurement and it goes away. And you're like, and so I've never gotten to the bottom of why the optimizer, like the planner, will just like suddenly plan and decide that it doesn't want to use this index, and because of the union that's going on, and then suddenly it will come back, and I've never been able to like get it to tell me why it's making that decision in a comprehensive and consistent way. There could be some cardinality thing I missed, but
Does Mongo have stats issues like MySQL and
it can. I think the bigger problem with Mongo is how the query planner works. And I'm sorry, I kind of assumed that it, well, no, no. Well, in the query optimizer, yes, but you have to understand how the planner gets to the point of the stored plan. And this is an important caveat. I thought it might have been covered in this morning session, but so what happens is it has a stored plan of the last time it had a winner. And when it runs a new query, or you run an explain, it runs all permutations and then figures out who the winner is and kills the ops for the other permutations. And this works good in some cases, but the problem is if you have very inconsistent cardinality, because your collection is like storing 15 different versions of a document or 15 different types of documents in one collection. I've seen people do that too. It can get really confused and start doing some really weird stuff. But what most importantly I've seen is I could have a good plan that it's doing a union and stuff like that, but then all of a sudden it decides it's not doing that, and all of the data that it provides is only for the winning plan. So I don't know the state of those other plans on why it did that. And so in Mongo, you have the ability to clear plans and set plans and lock plans and do a few different things to do some behaviors more than MySQL can do. But it's not based like MySQL is on a traditional stats that are updated. It evaluates the stats each time. It's looking to see if when I ran this query, did I do considerably more work or take considerably more time than my stored plan said I should have? If I did, I should reevaluate my plan. Obviously, I'm on the old understanding of this thing. And what this means is when you have high variability of cardinality in these different queries that are coming through, there is a chance that it is constantly going to be replanning itself and confusing itself. And so that's why they've tried to do some of the stuff with the plan clear and plan lock kind of mechanisms, is they've been trying to work around those things. So creating an index, simple, ensure index, nothing special there. Compound index, I'm sure we've all made compound indexes in Mongo. Array indexes. Single best and most evil thing that exists in Mongo. It is great that I can index an array. It is great that I can do those types of things, but it is also terrible that there are not red flashy lights everywhere that somebody is doing a multi-key index to go, your index has this right amplification factor because the average list size for this array is this long. I really wish there was something that warned people, or like when you went to do it, it would be like, hey, there's a 1,000-to-1 ratio on this list. Are you sure you want to make this index?
Are there any decent tools that can help you make that decision ahead of time? Like something that would take away the interface?
Aggregation framework. I had, I don't know if y'all still have it, but I had some scripts that literally were aggregation pipelines that would literally look for an array on a collection. If somebody wanted to make a array index, would look and measure what the maximal length of that list was, and then come back and report that as the risks so that the team would be able to go, yeah, this is a risky behavior. Are we sure we want to do this? Because it might be fine, because it might be a very static type reference collection, but it could be user blog posts or different things like that that have gotten out of control and become an unmaintainable mess that stalls the system, because my one write now became 1,000 index entry updates. My entire index is now rebalancing. Therefore, my index is stuck in an exclusive lock for a prolonged period, and everything else gets backed up. And people are like, well, why did the database just stall? And you're like, I don't know, but it's better now. And then you have to dig into it and you eventually realize that it's that multi-key index. And so I love it and I hate it in equal portions. I think there's a blog on the Percona blog on how to find those as well. And then obviously full search. I didn't talk too much about it, but it's one of the features. It's useful-ish, I guess. I don't know that many people with Mongo that use the text index, full text index stuff, but sparse indexes, this will help a lot with the cardinality problems I was talking about with the planner. But the problem with sparse indexes is you can run into limitations as far as if that column, or if that field, I shouldn't say column, if that field is used in another sparse index, you can run into some stuff. So you kind of have to plan out your sparse indexes a bit, or it will start throwing errors when you try to create more and more of those sparse indexes. So the hash index, it's a hash index. This is kind of what I alluded to earlier, where I had used this type of hash index on top of another thing to create a compound index for a shard key. I've done some stuff like that. Sometimes you have to trick Mongo into letting you do it. And sometimes it's perfectly happy with the behavior. GeoQueries, does anybody do GeoQueries? I don't find them very good in Mongo. I would much rather use GIS with Postgres, but I can't say that. But it has some cool features. There's some of your standard objects and structures that you would expect. It has matured a lot in the newer versions of Mongo, but still, it's useful for some certain stuff, but I question what percentage of the Mongo user population uses Geo, and how much of it was just a feature that we added, never took off and never got removed kind of thing. All right, so sharding management. There you go. All right, so in this section, I'm going to go through, I'm going to talk about the balancer and chunks and splits and migrations and jumbos. So this is probably, if you're doing sharding, the most important thing the DBRE team can be working on. More than anything else, it's this, because this is what's going to go wrong. So chunk management and smooth between what version you're in, but basically it's a range of data that exists on a MongoDB that can be moved between shards for balancing purposes. Nothing crazy or magical about that. I meant to change that to balancer. The balancer itself is what monitors and maintains, checks for the balance and all that kind of fun stuff, and moves stuff around. What does heavily loaded mean as far as a shard? This is what I was kind of talking about earlier. Depends on your use case, multi-tenant, and a whole bunch of other things. It could look balanced from a chunk perspective and be completely imbalanced from a size perspective. It could look balanced from a chunk perspective and be completely imbalanced from a CPU perspective. And you just have to kind of monitor these things and look to see if you have an errant shard behaving outside of the rest. I use Datadog a lot in my current role. And so I use box model stuff with Datadog to figure out if one shard isn't like other shards and send me alerts on that kind of stuff. Splits, this is when a chunk gets too big and it gets split. The mechanism for it depends on the version that you're at, but it splits it. The problem is, we kind of were talking about the tenant problem earlier. So if I only had sharded on social media platform earlier in that example, then when I got to Facebook, I would have 75% of all my data in a chunk, this ginormous chunk. Mongo wouldn't know how to split it up, wouldn't know how to break it up. And so that can be a real problem. But jumbos aren't just caused by that. Jumbos can also be caused because when you are doing normal activity, your chunk is growing and it wants to split it. If something goes wrong in that split operation, if the node is restarted or crashes at the moment it's doing that split operation, that chunk might not get split, it might continue to grow. If that occurs and it crosses a certain threshold, it's just marked as a jumbo by Mongo. It's never moved again, it just stays there, never looks at it again. You can, and I'll talk about that. And so you can manually call split on it. You can unmark it. There's things that we can do, but these aren't things that are automatically done. And this is why I'm kind of saying that this is one of those important things that the DBA, DBRE team should be looking at and should be maintaining, because it's not like Mongo, even if you're on Atlas, it's not like Mongo throws up a dashboard that says number of jumbo chunks. And if that goes up, somebody should go look at it, throw an alert. It doesn't do that. And it's crazy to me because they know it's a problem, but it also makes sense because they know it's a problem. So they don't want to talk about it. But as far as chunks, the other thing I want to talk about is migration. And so what happens in a migration, and this kind of comes back to those reads we were talking about earlier, is it locks the metadata is the first thing it does. It then copies the data to the new shard. It then changes the metadata, unlocks the metadata, and normal processes can continue. And in the background, a delete of the old chunk is occurring. And this is important because that delete is not guaranteed on when it will finish. That delete in previous versions of Mongo and potentially future versions of Mongo, if the node crashes and is restarted, might forget it was doing that delete cleanup. For a long time, it wasn't persistent. Do you know if they fixed that finally? I don't know. I don't think they fixed that. I think they call the command to do the cleanup, and it's only in memory. There's nothing on disk to say, I am doing a cleanup for chunk ID 1234. And so that if it restarted, it would resume said cleanup job. And so this is where a lot of those orphans and stuff like that can come from over time. And this is where your reads could become very, very stale, potentially. Because it could be that like 3 weeks ago, a document got orphaned, and you've been updating it in this other shard everywhere else, and then you do a scatter gather with read preference set to something, and it manages to get caught in that query. That's how these things can happen. And that's probably the most dangerous thing to me in this case is if the application receives both the current document and the version of the document from 3 weeks ago, what is your application going to do? I don't know. I'm pretty sure your developers never thought that would occur. But it's important. And so I'm not saying you will have data because it depends on the version. It depends on a whole bunch of cases occurring, but it's possible to have duplicate data. So if users are reporting weird duplicate or data that should have had a different value to it, it's worth checking to see if you have those orphans. So jumbo chunks. This is an aggregation pipeline for how I find jumbo chunks most of the time. The thing is, it's not necessarily accurate. Sometimes I need to actually take these chunks and I need to go run the data size command directly, and I need to do those things, but that wouldn't fit on the slide. But this is a good starting point to help you find jumbo chunks. The other thing is in the metadata, there is a flag for if it's a jumbo. So you could just query the chunks collection and say which ones are jumbos. I have found that it could be a jumbo and not marked as a jumbo yet. And so that's why I run this query rather than the jumbo true query. Because I'd rather find stuff that is going to be marked in the next hour or so, the next time something tries to do something with it to get marked as a jumbo. But this is how you find a jumbo chunk. it needs manual intervention. Fixing a jumbo chunk, easiest way, if it can do it, the easiest way is you just go into MongoOS and you say sh split, and you give it the value of a chunk, a value inside of the chunk that you want split, and it will figure out where to split it at. Normally, that's the best way to do it. There are cases where I wanted to split in a very specific position because I wanted to split this chunk into like 8 or 9 parts in one go, as opposed to go through multiple cycles of splitting it. And the other thing is, if you have a bad shard key, there's nothing you can do other than until you reshard. Because if you only have one field in your shard key or 2 fields in your shard key, and the cardinality is 1 across 100,000 documents, there's no way to split that 100,000 document chunk into 50K ranges, because there is no range to split. And so in those cases, you will just end up needing to reshard and solve that problem. But what I've done in the past is I've created a separate shard that I would move those bad boys to. So that's one of the ways I dealt with that in the past, is I just kind of moved them off so they quit disturbing the well-chunked parts of the system, and they were more on an isolated system. You can do it. It'd be better if you can reshard, but sometimes it's a lot harder to reshard than you would think, because the queries on that collection cannot guarantee they would always know all the parts to the shard key that you would need. And then that creates getter-gathers, and because they're doing sorts, then it creates a whole cascade of problems that I kind of alluded to earlier. So sometimes you have to accept that you will have a jumbo and you won't be able to split it up. But like I said, you can control those by understanding that you have them and understanding how to move them to more isolated hardware. So disaster recovery, DR is not about multiple regions. It's not. It's about continuation of service. And so the question is if my Mongo was built to be US East and US West, but my applications only existed in US East and my team really couldn't deploy them to West, the extra latency I added there might break my application. So I might be better off picking and living in a region that has 5 availability zones instead of 3 availability zones, and just being AZ DR instead of region DR. Depends on your business requirements and stuff like that. I can't say too much more there. But that gets into the how much latency and data loss is acceptable. Because this is the thing, is are you willing, from a DR business continuity perspective, are you willing to have a replica member in East and a replica member in West, and say that your query, your insert must arrive in East and West before it's acknowledged? Are you willing to take that 60 millisecond hit, or are you not? I think that's a trade-off that you're going to need to educate the business on. What do they want to do there? If it's AZs, it's not as big of a deal. You're talking about 15 maybe in your top end, but going multiple regions, or worst case, multiple continents, it gets to be a much bigger challenge. Can it be using delayed replication is also a good question I ask a lot, because one of the things that I do a lot is I will have a replica that is delayed in my DR region, and I will have a replica that's real time in my DR region. And the reason I do that is if I hit a bug in Mongo, or some developer deploys code that does something terrible to the data content set, do I have a copy of that data that I could sever from that replica set and then repopulate the whole replica set from? I like to have those kinds of options, but it all depends on what's in your Mongo system, how big your Mongo system is, and how complicated that would be to manage, and how feasible it is. If you have 50 shards, having one of those nodes is great, but are you really going to get to all 50 of those nodes in time before you run out of that delay factor to be able to?
That's fair, you were talking about having a whole another 50 delayed shards anyway, right? I mean, a whole other 50 delayed nodes.
Yeah, you have 50 delayed replica members in your DR region. And so you would have 50 nodes, but the question gets into, if I set my delay to 30 minutes,
Well, you have to have automation. Like if you have that scenario,
yeah,
it's separate. Like you said, it's not going to be a manual process.
yeah.
You have to really.
Yeah, and I guess that's the question is, do I have that tool? Am I going to build that tool? Is it worth the investment in doing that? It's all based on different business, what you're storing in the system and what the business's acceptance to data loss is kind of how that all plays in. But delayed replicas are really useful for that kind of thing. And I won't say that it has not been an occurrence in most .0 releases of Mongo that something deletes or corrupts data, and then they put a 0.1 out a few days later. So it's not been an uncommon pattern to have to deal with. Other things with DR and BCP is using tagging to do local accesses to different information, or to set the read priority and write priorities on what you're writing to guarantee business continuity for your critical data, but not guarantee it for data that has a more acceptable loss ratio. Like that's all types of plannings that you should think about. Sharding, I guess my only point with sharding is very rarely have I ever seen that you would only want a shard in a backup region or something like that. Normally I would want the members across the thing, but I have seen a few times where companies were actually doing that. They were having a shard that had more historical data live in another region than their live data set, so that if they lost their main system, they had a high guarantee that they would have their historical data still. I think that's a wrong approach. I think you should be thinking about, well, how am I archiving that data into S3, Snowflake, or some other data lakey approach, rather than necessarily using Mongo to try to facilitate that behavior. And monitoring, I just kind of wanted to cover like New Relic, Datadog, several nines, PMM. All of these are great tools. Ops Manager is also a good tool for sort of monitoring stuff. But I have settled more on using Datadog that also is ingesting custom metrics from CloudWatch as my main pattern for stuff in recent years. Percona is good. The challenge that I have with Percona right now is it doesn't hook as well as Datadog into Okta and other tools that the rest of the enterprise uses, and it doesn't hook into the traces that maybe the team's using with New Relic or Datadog with. And so I want that visibility available for being able to debug the whole stack from application down through the database. And so I like PMM. I haven't figured out yet how to get it to sit more naturally into the stack. And so what happens is my team runs PMM, and we send stuff to Datadog so that we have a lot more metrics in PMM than what we send to Datadog, because Datadog costs a lot of money for custom metrics. But it gives us as the database team the visibility, but it still gives the application teams a large amount of visibility in their own areas. Do it yourself monitoring, there's memory, disk IO, all that kind of stuff that you would expect. But also things that I look at is I almost always have canary queries in my setup that are monitored. I always am looking for when was the last election, how long has it been, like how many elections have I had in a certain window. All those types of things are things that I build a lot of my P1 alerts on, more than number of healthy hosts, because I don't care, when I'm monitoring Mongo, I don't care if one of my replica members failed. I care if it stayed failed or if I have elections flapping in some way, because that's more a user impacting problem. Yeah, it's also one of those things. It's like having an election to me is a P3. It should be a ticket to your Jira board, your Zendesk, whatever you use for your team's ticketing system, that somebody should look at tomorrow. But nobody should be woken up just because a node failed. But if I went into read-only mode on my replica set because 2 nodes failed, yeah, somebody should be woken up. If inside of the same hour I have noticed more than 2 elections occur, I should probably wake somebody up, because that means there's probably a memory bug or memory limit or something that's occurring that's causing it to flap like that. And so like that's kind of how I approach it. I'm very cautious with the number of P1s I allow, and I will fight until I'm dead to keep CPU alerts from being P1 alerts, because that's stupid. It's not the way to run a stack. It should be whether the cluster is healthy, not an individual node is healthy. That said, I also watch for our indexes building our, yeah.
Sorry, those sorts, those underneath sorts, I'm guessing they show up as high CPU.
So they show up as high CPU, but there's also a counter. It's called scan and order is the status variable. And if that counter is going up, or more importantly, if that counter's increase has changed because a release just occurred.
Are you talking about the velocity or just?
Yeah. Just like if I have a linear curve that's happening this, and then a release happens and it starts going like that, then clearly they introduced a new query that needs to be indexed. And I even, in some stacks that I work with, I even put in failures on that release if it notices that spike occur, because then I'm stopping something from creating a potential incident quicker, and they're able to then react to that quicker, and our CI/CD pipeline doesn't get as messy because we allowed something in and then 5 other things came in, and then we wanted to roll that one thing back, and it gets all sorts of confused and complicated. The quicker I can say, no, that was a bad release, it's causing extra pressure on the database, the better off we are. I don't know where all other teams are. Some teams aren't that advanced in their release detection systems, but you can do that for if more long-running queries are happening, if more scan and orders are occurring, if, I don't know, I see a marked CPU increase. All of these things are things that I would trigger at least a certain number of points towards marking something as a bad release. Because I believe in using rules engines that you can create weighted rules that if you cross this threshold, you get shut down. If you don't cross it, then cool, whatever. So a lot of the typical kind of warning thresholds that I look at for a lot of this stuff is this kind of stuff. That's actually another thing that I look at in production quite a lot is, did my number of indexes change? Because did somebody just turn on a feature toggle that then triggered an ensure index? That could trigger an ensure index. So basically they've shipped code for this feature that's turned off, but when they turn on that feature, that code also basically deploys itself by creating the ensure index it needed. I've run into cases where I got burned by that. So that's just one of those things that I've looked at in the past to do, is to check. Just if I'm having an incident, I would like to have a graph that would show me that the number of indexes changed, because that would help me understand, oh, my index has changed. I probably have locking because the foreground index is happening. Cool, let me go look at that. And the amount of time you've just short-circuited by finding that is so helpful. But also what percentages and queues and stuff like that are useful as well. But yeah, that's everything I kind of wanted to cover that I could think of. Kind of just a bit over time, not too bad. But if you want to ask me any more questions, I'm available. Talk to me. I also have a topic tomorrow on more on the WiredTiger settings, and I'll spend a little more time on that. I kind of rushed through those a bit today. All right, thank you.